your names on the screen are accurate. So this way we could provide credit for those that are here for ACVREP or for MSDE credits. So just make sure we have your name for attendance. Sometimes it says iPad, blah, 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 and we don't know who that is. So just retype your name into the screen or just send me your name in the chat box. That would be great. Okay, are we recording? Good. Okay, we're recording. Okay, so here we are again today, Matt. We're ready.
All right. All right, I'm ready. Thank you. Thank you
Okay.
very much, everybody, for coming back today. And I'm just going to share my screen here. Let's see. Oh, it says host disabled participant screen sharing. I just need to.
My bad. I need to give you all the powers. Let me do that.
Oh, I need to tell you the ACVREP opening code. I had it in my head. It was almost like my brain thought I had already said it. I didn't say it. Okay, the opening code for today is ocean. Ocean, and I will also type it in the chat box if Jen Wills doesn't beat me to it.
I will not, because I'm making people co-hosts. But Matt, you should be good to go now.
All right.
Okay, great. Thanks a lot. And somebody just said hello from Montreal. So hello. Thank you for joining us. That's awesome. All right, I'm going to click on share video, share screen. Okay, here we go. Oh, we got to get rid of this thing again. Let's see, Control Alt Shift H. Okay, there we go. All right, and before I get started, whoops, it's coming up again. Okay. Before I get started with the content for the first part of today, which is the, kind of the visual recognition and 2D image interpretation in kids with CVI, I wanted to just share this book. This was the one that I mentioned yesterday, and it's called, I had the title a little bit wrong. It's called Understanding Facial Recognition Difficulties in Children. And then the subtitle is Prosopagnosia Management Strategies for Parents and Professionals, edited by Nancy Mendick. And then here's the Amazon link for it below. And just again, I found it very helpful for whether just it's so much helpful information. And I think the cool thing is that it's written by people who have had prosopagnosia their whole lives. So really, really great insights. And I feel like it's helped me better appreciate what some of my students might be experiencing when they look at a face. Okay, so an updated agenda for today. Day 2. So I plan to start off with visual recognition. And for those of you who've seen me present on the 2D image assessment before, there's going to be some familiar material, like especially in the beginning and the end. But in the middle, I've put a lot of new images and a certain way of looking at and interpreting students' responses that I haven't really presented on much before. So I'm excited to share that. And then after that is a presentation I call Coloring Complexity, where we'll talk about and really look at as deeply as I can go into it and understand it, why can color be such a powerful support for some kids with CVI, and what are some of the ways we can really capitalize on that and tap into that. And then finally, the impact of CVI and complexity on math and the development of math skills. Some of you may have seen my presentation on CVI Now. It's also on YouTube. It's called CVI and the Math Mind. This will be a lot of the first part of that. I decided not to show the whole thing because some of you may have already seen it, but I wanted to really emphasize the first part and also stress how color can be an important sort of intervention for a lot of these math difficulties as well. And then in day 3, I expect to probably start off by continuing and finishing the math presentation. Maybe not, maybe we'll finish it today. And then today is going to be more presentation heavy. And then tomorrow is going to be more, we're going to spend one of the hours tomorrow doing a video case study using the What's the Complexity framework. Lots of videos of a student named Paul in phase 2. And we'll be rating the environments, rating his activities. And then you'll have a chance at the end of the day for probably about the last 45 minutes to an hour to think of a student on either your own child or son or daughter or someone on your caseload if you're a teacher, a student who has CVI, and we'll be completing a task bank and individual complexity profile for that student, and with me here so I can answer questions. You can share out with the group, and sort of like a hands-on kind of workshop format for that last part of tomorrow. And you'll have all those handouts tomorrow. As far as handouts for today, there's really none that you have to worry about. The only handout that's in the folder for today is one that I'm going to be showing on the screen anyway. So I just put it in the folder in case anyone wants to use it with future teams as an activity. Also in the handout folder for today is a separate folder called 2D Image Assessment. So in there, I put all of the materials, digital copies of all of the materials for my 2D image assessment that's in Christine Roman's book at the end of chapter 4. And I say mine because really people should feel free to come up with any version that they want. And I like to say that mine is just an example that works for some of my students, in that most of the time I end up individualizing it student by student. But the version that's in Christine's book is I think, a good example. And that's available for everybody to use. And then I also have another version of it that I created more recently, that Dr. Lotfi Marabet is using in one of his studies at Harvard, to test 2D image recognition in kids with CDI. And so they're both a little bit different. And I think both have sort of, I use one with some students and one with other students. So anyway, those are both available for you in that folder.
Hey, Matt. So your menu bar friend is back.
Okay. Thank you.
You're welcome.
Man, this key command is like an Apple key command. It's like 4 keys. There we go. All right. So this is 2D image interpretation. Here we go. One of my favorite things to present on. All right. What is this? Let's just feel free to shout it out or write it in the chat, and maybe Donna could say what people are writing. What is this? Can you recognize it? And some of you are probably wondering, is it a trick question?
Looks like a strawberry.
Looks like a strawberry. If I were to tell you this is not a strawberry, does anyone have any other ideas of what it could be?
A clay strawberry.
Oh, all right. I like that. We're getting in the ballpark. That's close. It's actually cake, right? Is it cake? If anybody's seen that Netflix show, is it cake? Or if you've watched the British baking show, you might have seen that they have this one day where they try to make cakes that look like other things. And anyway, I'm borrowing this concept from Nye D'Amato, who writes the CVI Perspective blog, and they have a post with the what is cake, with the is it cake theme that ties into visual agnosia or visual recognition difficulties, and so it's going to tie in throughout the presentation today as kind of an analogy. Okay.
Your menu bar is back.
Oh my goodness, it's like relentless. All right, there we go. All right, thank you. Whoops. Okay, so now I'm going to ask you what something else is. What is this? Okay, and again, feel free to call out, on their microphone or write it in the chat.
Scissors.
Scissors? What if I told you that was incorrect?
How about a picture of a scissor?
Okay, you guys are good. All right. Yeah, right, exactly. So it's a picture. And what's a picture? Well, a picture, according to Daragowski, a picture is a pattern of lines on a flat surface that depicts some aspect of the real world, right? And of course, all of our visual systems we see so effortlessly, and we can turn these lines into what they're really supposed to represent so effortlessly that we look at this and we say scissors immediately, right? Where it's really just a bunch of black lines on a flat piece of paper. Whoops. Okay, so this kind of goes along with a story. When I was working with a student in late phase 2 who was in kindergarten at the time, and he had a worksheet the day before I visited him, and the teacher asked him to circle the scissors on the worksheet, the pair of scissors, like a picture of it. It was a black and white line drawing, and he got it incorrect. He circled something else. And the next day, the teacher asked me, well, why do you think he didn't know which one the scissors were? He uses scissors almost every day. If I ask him to go into his desk and find the scissors, that he can find them. So, why did he get this wrong? She said, I made it big enough, right? I made it bold enough, right? He can see it. Do you think he can see it? And I said, well, I know he can see it based on the, vision assessment I have done with him. It was plenty big. It was plenty bold. But I said, I don't know what he's seeing. So let's ask him. So we sat down with him and we looked at this image of scissors. And I said, what do you see here? And he said, bicycle. And I asked him, okay, can you point to one of the wheels? And sure enough, he pointed to one of the handles, thinking it was the wheel of a bicycle. Then I was curious, was the issue that it was oriented in a way that made it, that was unfamiliar to him, and that's why he said bicycle? Or was it more that it was a black and white line drawing and didn't look much like the real version of scissors that he was familiar with visually? So I pulled up a picture of these scissors on my iPad, just on Google Images, because I thought they looked more like the type of scissors he would be familiar with. And I said, what is this? What do you see here? And immediately he said scissors. So that was sort of, this was right out, this was like maybe like a few months after my time with Christine Roman in the CVI Phase 3 boot camp in Maryland. And so I was fresh out of that, really thinking about what she had taught me about, you know, abstraction of images versus objects and different types of images and board maker symbols and all that stuff. So I was really starting to get into, this was sort of the beginning of me really asking my students a lot of these questions and trying to get to the bottom of what are they seeing when they're looking at something. I like to share this example. This was several years ago. One of the TVIs who I work with, one of my colleagues, had brought this image along with a bunch of other images to one of our CVI committee meetings that we would meet once a month and kind of share ideas. And she said, okay, I'm working with a speech pathologist in one of our schools, and they're coming up with a new communication system on an AAC device for one of our students. And they asked me, do you think these images are appropriate for the student? And she said, I didn't know what to say because the student's nonverbal and I had never really been able to figure out how to assess that. So I'm not really sure if the student can interpret them or not. And so she had this idea. She said, what if you guys, meaning the other TVIs, take these images around to the other students you have on your caseload who are verbal and can tell you what they're seeing, just to get a sense of starting to imagine what a symbol like this might look like to some students with CVI. And so we did that. We called it the Abstract Image Tour of Connecticut. And we took this and a bunch of other images around. And I used this one because I feel like I got the most interesting responses for this one. So one student said it looked like a house. Another student said a square. Another student who said a square as well. And then his TVI pressed him for more information and said, can you tell me more about this? And he said, all right, it's a quadrilateral. Another student, one of my students, said it was a sign with a face on it, right? Can you see like sort of these waves might look like the eyelids, and then this wave might look like the mouth. And then one of my other students said birds, right? And that's so obvious to me now. Like, yeah, you've got the blue sky with those squiggly lines, could be birds flying. And then I asked that same student several years later what he saw when he looked at this picture. I was curious if he would still say birds, and I hadn't shown it to him for a couple years. And I said, what is this? And he said, well, it looks like a board with a red eraser. So he was thinking like the whiteboard or the smart board they use in class with a red eraser next to it. Within maybe the little squiggles were handwriting on the board.
Hey,
so anyway,
Matt,
yeah.
Your bar is back.
I wonder why that's so funny. Like if I press escape, that automatically puts it back, but I haven't been pressing escape. Thank you. Please keep telling me because that helps because I get so lost in my zone here that it's get rid of it. There you go. Okay. So anyway, we went over dorsal stream and ventral stream yesterday, but I just want to emphasize at the beginning of this presentation that we're really talking, when we talk about visual identification, although there's so much interconnectivity between the two streams, we're really talking mostly about the ventral stream function of identifying what we're looking at, like objects, images, faces, letters, words, numbers, and so on. Okay. So this closely relates to, or it's directly related to the sub-characteristic on the CVI range of difficulty with complexity of object, right? Sometimes Christine will kind of say object/target to indicate that it's not just objects, but it can include also images, pictures, numbers, letters, things like that. Really, any of those items or symbols that we identify in our ventral stream. And so I like to, sometimes you'll see me use object/targets here. But anyway, so, when I was first starting off in the field, I was basically just taking it super literally. And when I would do an assessment, I would just kind of like assess whether the kid could look at certain types of objects or not. But then after taking that phase 3 boot camp, I started to really see how like it goes way beyond that. It's really once a kid gets past early phase 2, it really becomes a lot more about not only can they look, but can they interpret what they're looking at, and not just objects, but all sorts of different visual targets. I did a lot of research after that boot camp to kind of delve into like what's the research say on image recognition for people in general, and especially for people with brain-based visual impairments. I found that there was quite a bit of literature on adults with brain-based visual impairments, but really none on children with CVI as far as the research fields went. So I delved into that adult literature to see what parallels I could find. And I found some really helpful stuff. So one of the people that I discovered was Martha Farah, who was a prominent, or she is a prominent neurologist. She doesn't work as much with vision anymore, but the whole beginning of her career, maybe the first half of it, was neurology and vision. And she wrote some really seminal, pretty still incredible today, books on visual processing in the brain. And so reading her books, I learned that in general, for people with brain-based visual impairments, images tend to be more difficult than objects. And that's what I was finding with my children with CVI as well. Those were the patterns I was seeing. In that among the different types of targets we could look at, that color photographs tended to be easier than more abstract types of images, like black and white line drawings and cartoonish type drawings and things like that. And also from Farah is this statement that this loose hierarchy of difficulty is supported in the literature on brain-based visual impairments. So there does tend to be, especially when you have sort of an impairment or difference in the way that your ventral stream processes what you're seeing, there does seem to be a hierarchy of some types of images being easier than others. I'm going to get rid of this thing here again. Okay.
And we also have a question, Matt.
Sure.
What was the name of that researcher again?
Martha Farah. So, let me go back and I think how many R's are in it. I'm going to backtrack for a sec. I think it's Farrah. So the two books I would recommend by her are, she has one book called The Cognitive Neuroscience of Vision, which is like a eyeball to starting at the eyeball and retina all the way through the brain about like how our visual systems process the data from the eyes. And then she's got another book called Visual Agnosia, where she has a chapter on each of the main types of visual agnosia that had been identified at the time. And it's still, a little bit of it is maybe slightly outdated, but there's so much rich information in there that it's one of my favorite resources still. Yeah, so it's just fast. I find it fascinating. Yeah, so Martha Farah. So why are images, for a lot of people, more difficult than objects? And it's probably not for everybody, but for most of my students, I've seen this pattern when I've been able to assess it. So this is the next two slides are kind of how I like to explain this. So when we look at an object, let's say in this case it's a car, it's a real car, it's out in a parking lot. We're standing out in the parking lot looking at it. We're using two main types of visual features. We can group those into lower order visual features and higher order visual features. The lower order features are just ones that occur earlier in our visual system for the most part. Things like color, luminance cues. So like the way that the light kind of reflects off of the surface tells us about its dimensionality and shape. It's visual texture. So we could tell by looking at a car in a parking lot without even touching it, we can tell visually that it's going to be hard and smooth rather than soft and fluffy, just by the way the surface looks. And then actual size, right? The actual size that something projects onto our retina helps our brain immediately. If we think of Christine Roman's Google search analogy, it immediately narrows down that Google search to things that could be this size that I know of, that I've seen before. And then also, I didn't put it here, but context. Right? If we're in a parking lot, that's another thing that helps that ventral stream Google search narrow down the categories of things that we might be looking at. So those are sort of like the earlier visual features that happen earlier in our visual processing. Context isn't really earlier. I mean, that's more of a cognitive thing. But anyway, most of these other ones are sort of earlier visual system cues. And then higher order, we're also at the same time we use those lower order cues to kind of narrow down the Google search, right? But then we got to be really precise and pinpoint the exact thing that it is. by using our higher order visual cues that are more top down. And this is where I think salient features that Christine Roman Lancy has really pioneered really fit in the best, is these higher order visual features. We know the general vague category that it might be from the lower order features, but from the higher order features, we know that it's a car, and not only it's a car, it's a convertible and it's a Corvette, right? Those are those salient features, those more detailed features that help us to really pinpoint exactly what it is. So we're using both sets of cues. And, students with CVI tend to struggle with both, right? I mean, the lower order cues could be impacted. But I think it seems to be those higher order cues that seem to be even more difficult for a lot of my students with CVI, those salient features. All right, so if we think about that, then I think this quote from Martha Farah is really helpful. The progression from object to photograph to illustrations to black and white line drawings results in the increasing impoverishment of the lower order features. The lower order features that I think a lot of my students with CVI are disproportionately relying on due to their difficulty with salient features. And I kind of have this graphic here to illustrate Farah's point. Well, I'm getting better at noticing when this thing pops up. It seems like it has a mind of its own. All right. When we're out there looking at the real car in the parking lot, when it's a real object, we have a lot of these visual cues at our disposal, right? We've got color cues, luminance cues, visual texture, actual size, salient features, context, like where we're looking at it, right? As soon as we snap a picture of it, though, as soon as we take a photograph of that car, now we've lost the actual size, right? Because now instead of being whatever a car is 10 feet long or 12 feet long, now it might only be 3 inches long on a piece of paper, right? So we've lost the actual size and we've lost the context. Now, instead of looking at it in a parking lot, we might be sitting at a desk in a speech room looking at it. And so we lose that cue of context that's helpful in visually identifying what we're looking at. Now, what about when we go from photograph to color illustration? Now we've lost luminance cues, right? You can no longer really see the way the light is playing off of it, like in a photograph. And we've really, in a lot of ways, lost visual texture as well. We don't get that sense of metalness as much when we'll look at it visually. So now the only two things we're left with at this point as visual cues are color and salient features. When we go all the way to black and white line drawing, now we've lost every visual cue except for salient features. And I think, trying to sort of relate Martha Farah's work of people with ventral stream impairments to our students, who I think we know many of them struggle with ventral stream difficulties. This seems to really fit what I've seen, this pattern of most of my students do much better the more realistic and the more in color it is, and struggle as we get more to the abstract and more to the black and white. And I'll show you a lot of examples of that coming up soon. But
Hey,
first,
Matt,
yeah,
there's a question.
yeah, go ahead.
If a child looks at a windshield and says it's a rectangle, would this be an example of a higher order difficulty?
Oh, man, that's interesting. I mean, it says it's a rectangle and they're looking at, yeah, that's interesting. I mean, it's that to me, if a child looked at a car, well, so if they look at the whole car and they sort of zero in on the windshield and they say rectangle as their whole answer to that picture, then you'll see some of the patterns that I kind of like propose coming up. But I think that really fits one where kids see a single feature and they may not really notice the other features of the object or be aware of them. And they try to make a guess based on that single feature, and really nothing else exists except for that feature. And that to me would be an example of if you take a windshield out of the context of the car and you're not seeing the wheels or the hood or the bumper or the headlights, and you're maybe just seeing the windshield, which, because we know that some people with brain-based visual impairments process images piece by piece instead of the whole. So if a child's seeing it that way, then I would think they would be much more likely to say rectangle than windshield, because you have this rectangle thing now that's out of the context of what it belongs with. So that's just my initial thought about it. But yeah, I would say that's probably relates to more of that higher order visual processing of what some in the clinical literature might call something like integrative agnosia, where you're seeing maybe just parts and pieces of an object, but you're not seeing all of them at once. And so you're making a guess based on just maybe a single feature or two. I love that kind of question. And I don't know, that might not even be a good answer, but that's sort of like, I think it's so much fun to talk about it like this. So why is all this important before we even move on? Well, I think most of us who either have a child with CVI or who have been in the classroom trying to support a student with CVI, we know that a lot of our students' work might look like this, right? Getting handouts of black and white line drawings where they have to demonstrate cognition based on something that they may or may not be able to visually interpret. Or on the left, especially in the early grades, these really cartoonish, colorful picture books, these read aloud books that really might not bear any resemblance to the real thing visually for a person with CVI. So I think so many of the types of the types of images that are used in instructional materials in most schools tend to fall on that on the whole realistic photo to black and white line drawing spectrum or hierarchy. They tend to fall on the more abstract, more black and white, more abstract color side of things. A lot of times, not all the time, but I think that's why it's so important to really get a sense of, as best we can, how does each of our students do with different types of images. So, like I mentioned in the beginning, like this is the 2D image assessment that I have in my chapter in Christine's book, CVI Advanced Principles. It's just one example of what it could look like. You know, I put it together to kind of show here's what I've been using with my students. And I want people to know that they're totally free to because some people have written me in the past and say, well, I'm just concerned because like some of these images my student has experience with, but others he doesn't. Or, you know, my student's more at an object level right now. And it's what I usually say is like, please make your own. I feel everybody should feel free to make their own 2D image assessment or object assessment for every student that they have. Out of my caseload each year of about 35 students, and maybe 30 have CVI, I probably only do the 2D image assessment with, like, as it is here, with like maybe 7 or 8 of them. Because for the rest of the students, I'm really individualizing it based on what I know is more familiar through talking with their family, through talking with them, the types of things that I know are more familiar to them in their life. So that's just a caveat that the version I'm going to show you is just one possible iteration of what it could look like. And so the image categories that I chose for the assessment, I chose for 2 reasons. One reason is that these categories of images are the ones that I most frequently see used in school in instructional materials. They also just happen to coincide with one of the chapters in Vision in the Brain by Lueck and Dutton. There's a chapter on assessment, or maybe it's the chapter on visual perception, and they talk about that these 5 categories of images can be useful ones to assess for kids with CVI. So those are sort of the categories that I've settled on for most of my students, because I think they really run the gamut of what our students see in school. And so, you know, this is just a little section from one of my versions of the 2D image assessment. And you'll just see, like, for each item, like dog or backpack, you've got a different version. You've got the color photo version, you've got a realistic color illustration, you've got an abstract color illustration, you've got a realistic black and white illustration, and then an abstract black and white line drawing or illustration. Excuse me. And I want to see how my students can do with each of these types of illustrations. And what I usually do is, it's different for each student, or I should say it's different for a lot of students, but for a small core group of my students, I often present it like one image at a time like this on an iPad. If the student can verbalize what they're seeing, then I'll show one image at a time like this and say, what is this? Or what do you see? And I don't tell them if they're right or wrong. I just say, like, all right, thanks, or good work, or, you know, keep up the good effort, or, you know, that kind of thing. Just so that if I give the assessment again down the road, they haven't already gotten the answers from me. And then I usually record the students' responses in this form, and sort of get a percentage for each type of image and how they did on it. Okay, so let's look at some results that I've gotten with my students. And another caveat, the couple graphs that I'm about to show you, they're not really studies. They're sort of like informal data collection that I've done on some of my students, and then on some of the students whose TVIs or parents have taken my Perkins class, and they've given their kid the 2D image assessment as an assignment. So I've taken just 13 of those and just kind of parsed out the results. And so that's what you're seeing here. It's not a true scientific study. But out of these 13 kids in phases 2 and 3, they tended to do better with color photographs and realistic color photos, which you see in the yellow bars here. And then abstract color, realistic black and white, and abstract black and white were more of a challenge. When it came to ocular versus CVI versus not visually impaired, the not visually impaired kids in this, actually there were no non-visually impaired kids out of these 13. But when I compared it to the non-visually impaired kids that other people had done in the class, they got basically 100% on everything. And then for the kids with ocular visual impairments that other people in the class had done, because they didn't have access to a child with CVI, those kids did better than the kids with CVI, getting about 90 to 100% on each item. So kids with CVI out of those three groups had the hardest time as the images got more abstract or had less color. I also wanted to look at the data in a different way. I wanted to look at that group of 13 students and say, okay, what were their best categories, right? And some of them were tied for, some of them had two categories that were tied. So that's why these numbers, I just included both of them here. So that's why these numbers here come out to more than 13. So for 9 students, color photograph was either their strongest or tied for strongest. For 8 of the students, realistic color was either strongest or tied for strongest. For 3 of the students, abstract color was either the strongest or tied for strongest, which surprised me. And then for 1 student, realistic black and white was the strongest. And I circle those just to say, this is why I always tell teams it's so important to assess and not to assume, even if we're finding a pattern, or if I'm seeing a pattern in my work with students, that realistic color images and photographs tend to be easier for most of my students. I was so blown away by these students who that wasn't the case for. And that just drove home to me the point where I never want to assume. And I always want to make sure, because for that one student who does better with black and white, I could have just gone in there and said, oh man, you can't use these black and white line drawings. I could see myself doing this too. You can't use these black and white line drawings on the worksheet. He's got CVI. He's got to have color photographs. Well, that might hold true for many of my students, but not for him. And so it's so important to really try to get at to the bottom of what each kid can see. So I'm really excited right now that Dr. Maribet from Harvard Medical School, along with his team, have been, and I've been participating in this study as well, and helped create like the protocol and the images and everything. They're doing a real scientific study on this, which I'm glad of, because I've been showing this less scientific one, and I just want to see if the harder science kind of matches up. And so far it is. So far they haven't published a full journal article on it yet, but they're working toward that. They've actually recruited a group of kids in Italy, at a university in Italy, who is now participating in this study as well, which is increasing the population size of the study, and we'll get even better data. But out of the kids that they've seen in their lab so far, this is what they found. CVI participants were less accurate in identifying images and were slower to respond than controls. That's for any type of image. Now, real images were easier for those with CVI to identify compared to abstract images. And then finally, color appeared to be an important cue in helping individuals with CVI identify images. So it's, so far this more scientific approach is matching the patterns that Dr. Roman had taught me, and then the ones that I have seen with my students as I've done more with the 2D image assessment with them and everything. So that's good to see, but I think it's also, despite what might end up being these trends, I always just say to myself, I've got to assess each student, because until I assess him, maybe he would do better with black and white. I don't know, probably not, but you never know. Okay, so this is one thing that I've kind of added to this, my thinking on 2D image interpretation more recently. And it's trying to, I've always been so fascinated when my students answer incorrectly. I'm less concerned about whether they were correct or incorrect, and I'm more interested in what was their approximation. What did they think the thing was? And what might that be telling me? Like trying to be a visual detective myself, like what insight might I gain from their answer into how they're seeing the world? And these are by no means like, any sort of, this is just from my imagination, kind of what I'm noticing with my students and with the students who answer, with the participants in my Perkins class. Like, what are the patterns? Are certain patterns emerging? And it's tied in a little bit to the scientific literature as well on visual agnosia. So these three yellow bullet points here kind of represent the main categories of error patterns that I tend to, and again, the labels are imperfect, but just to sort of for my own thinking, I've been starting to group them in this way to sort of understand where my students might be coming from. So on one hand, I see students sometimes not really using features, not really seeming to notice any salient features. And when that happens, they're usually going solely by color or surface pattern, like they're over relying on those things because of the weakness in salient features, or going by gross form, right? Like the overall shape of something and kind of taking a guess based on that. I also see some students using single features. Like I think the person who asked the question about the windshield, that might fit into this category. And out of this category, I see students sometimes noticing one single feature, like the windshield example, and making a guess based on that. And it's almost as if, based on their answer, that they don't see the rest of the image. They're just seeing that one feature and they're making a guess, like calling a car with a windshield a rectangle, because maybe they're only seeing the windshield. And then the other pattern I tend to see under this category is the student will take a single feature, but they also, based on their response, seem to be seeing the whole thing, but they're over relying on a single feature to make their guess. So I'll show you examples of all these. And then I also see what I think are students using multiple features, but having difficulty with how they're integrating those features. In the literature, in the neurological literature, this is often referred to as integrative agnosia, difficulty integrating the pieces of an object into a coherent, understandable whole.
Hi, Matt, it's Becky.
Hi.
We have a quick question for you.
Oh, yeah, great.
Yep. Is it a study looking at only children with cerebral visual impairment? Are their CVIs being identified along with their results?
No, so that's a good question. So like it's not, that's where it gets tricky with the labels again, with cerebral and cortical visual impairment, I think, because the lab, to the best of my knowledge, the lab isn't distinguishing between the two. It's taking any diagnosis of CVI, because a lot of times I feel like in the diagnoses they receive, it doesn't really specify. It might say cortical, but it might just be because that's what the doctor uses, or it might say cerebral, but it might be just because that's the term their doctor is familiar with. So like, I think that whole part of it's tricky, but my sense is that more of the students that I know, some of the students who are in the study, and I could say that, yeah, some of them have cortical visual, what I would consider cortical visual impairment, or at least that I would say, I've used the CVI range with them because I feel like they have most or all of the 10 characteristics. And then some of them, I believe also, I would consider probably having more cerebral visual impairment, where they might just have, maybe it's just ventral stream dysfunction, or maybe it's just more isolated types of issues that are happening, or that it seems more subtle and that they don't seem to have all the characteristics. So I think it's a mix of both. So yeah, and I think that they for the students that I know who are in the study, they're definitely on the much later end of the CVI range, like mid to late phase 3. And my students who are in mid to late phase 3 tend to do pretty darn good on the 2D image assessment. Sometimes they get all of them correct. So it's still interesting to me that even despite that population of students, we're still seeing the same pattern of difficulty. So I think that's a good example where I think there's more overlap than differences sometimes. And so anyways, yeah, so it'll be interesting when the population from Italy is fully integrated and we get the data from that to see what it's showing when we have more students. Yeah, good question. So another pattern so when it comes to using multiple features, I think sometimes my students seem to be seeing more than one feature, but they seem to be over segmenting it. And instead of seeing those two features as bound together as part of the same object, tend to see it more separate, two separate or three separate things. And I'll show you an example or two of that. And there's another category that I call imaginative misinterpretation of salient features, where the student is using all or most of the salient features, but misinterprets the configuration of features as something different than what it is. And these are always so interesting to me. I'll show you an example of this in a few minutes. And then finally, what I just call ballpark salient features is that it's like the student's so close, they're almost there. They're getting warm, they're using salient features, but they need a little bit more of like that comparative language that Christine Roman uses, I think, to really get from where they are to where they need to be. I think an example off the top of my head would be like if I have a student that calls a bicycle a motorcycle or something like that, or a car a truck. You know, it's so close, but oh, we gotta talk about those salient features. They call a banjo a guitar, maybe, you know, that kind of thing. And then I think under all these, sort of spreading over all of these categories like an umbrella in green here is experience-based learning, right? Our students, really our students' visual library, or as Dr. Roman would say, their visual Google search, it's really like only as robust and well stocked as their visual experience, right? And so if they don't have access to the same type of incidental learning, and they have different visual experiences than their peers, then some of their answers, that difference in visual experience is definitely going to influence all of these categories, right? And again, these are just sort of like informal kind of like labels that I use just to try to like get a qualitative look at how some of my students might be using different patterns when they're looking at images. Okay, so let's take a look at some of these. So this is a student who looked at this bird here and called this a swimming pool, this abstract color illustration of a bird. And to me, this is an example of a student who is able to use gross form in recognition, and they're able to use color or surface pattern, but they're over-relying on those things because of what might be a weakness in salient features. Here's from a child in early phase 2. And I think, so they looked at this lamp, which I would consider a realistic color illustration, kind of realistic, and called it a princess. So I'm thinking, oh, wow, you know, are they seeing the lamp shade and seeing it as a really fancy dress? Or are they seeing the lamp shade as long flowing hair, and that little dangly string that you pull might be a nice earring or something like that, right? So to me, this is an example of over-segmenting. They're taking maybe a single feature or two and making a guess of what the whole might be. One of my students in late phase 2 at the time, he's in phase 3 now, looked at this slide and said, it's a ladder. And this was a pattern I see often with this student, where he seems to see one of the features but misses the other feature, and bases his answer just off of that one isolated feature. This is one of my favorites from this same student, because he also tends to over-segment, even when he does seem to see, or actually he's really good at this now, but back then, even when he did seem to see like all the features at once, he seemed to see them as separate from each other rather than as a whole integrated object. And so when I showed him this abstract color illustration of a toothbrush, he said he thought it was a bus driving down the road. And just, wow, like the level of insight that this gave me, his response gave me into how he was seeing, was just so valuable. And I love it. I love the ingenuity, the creativity, the intellect here. I mean, he's so, like, look how smart that is, a bus driving down the road. Like, he wasn't, because of his CVI, he wasn't able to interpret this level of abstraction. So he came up with something creative that, like, made up for that. It was just, and gave me a great place to start in introducing that comparative language. All right, and this gets down to a bunch of the categories, but specifically, I think experience. It's a good example of experience-based errors, right? So when I showed the same student this black and white abstract illustration of an elephant, he said it was a remote. And I thought, you know, I thought that it was the, I saw the trunk and the way it looks sort of like a curved kind of rectangle-ish sort of thing, like maybe a TV remote, and maybe those lines were lines of buttons. But then I was presenting this slide at a conference years ago, and Lindsay Hillier, a person who's really into CVI from Canada, said, "Hey Matt, does this student have a Sony PlayStation at home?" And I said, "I don't know." I knew he was a really avid video gamer. He and his brothers would play together a lot. But when I got home, I asked him, and sure enough, he's very familiar. He has a Sony PlayStation, plays it all the time. And this is a Sony PlayStation remote. So now when I see this elephant, I always think of that Sony PlayStation remote that my student might have been envisioning it as. So going by the closest thing in his visual Google search that matched that experience. Okay, so let's try some together. I'm gonna for the sake of time, I'm not gonna probably ask the group for all of these, but I want to ask for some, kind of what you're seeing here. So, you know what I figured out? I'm gonna admit this person every time. This pops up whenever there's somebody in the waiting room. That's what's happening. And it's no big deal. I'll just hide it. But I just figured out that's what's going on. All right, so which error patterns might the student be, what patterns visually might they be following? All right, so when my student, oh no, this wasn't my student. Some of these are from my Perkins class as well. So when the student looked at this microwave, they said, Mama's phone, right? What do you think? I mean, is that, I'd love to hear somebody speak out or put it in the chat. What might be going on here? Is it not using features at all? Is it using gross form? Is it using a single feature or multiple features? What level might experience play in this? What do you think?
This is geometry shape 3D. Buttons.
Yeah, right. So it's like the overall shape, right? It's like it's shaped similar. It's got the same gross form as a cell phone, maybe. Especially if you're not seeing how deep it is, right? If you're just sort of looking at the front surface, the front face of it.
Parts of the whole, shapes and button
Mhm.
circles. Yeah.
Yeah.
Numbers.
Yeah, totally, right. Yeah, exactly. Like the button could look like a home button, maybe. The numbers could look like the buttons on a cell phone. Yeah, there's so many, in experience based. You know, somebody pointed out once that, well, how many kids at certain ages, depending on their age, have visual experience with a microwave, especially a kid with CVI, right? Like our microwave in our house is way up by the ceiling. And so they might hear the sound a lot of their mom putting something in the microwave, hear the microwave beeping, but they might not have a ton of visual experience from the distance they're at seeing that microwave and really getting to know its features. But they might often pick up and play with their mom's phone, right? So I could see that as definitely that experience influence. All right, so one of the students looked at this cat and said, "Hook." What do you think here? What's going on here? What pattern? And you don't have to even use one of these patterns. You can come up with your own too, or your own sort of name for it. These are just sort of, again, my kind of the way I think about it.
Single feature.
Yeah, I think so. Right. Single feature, right? They're seeing that tail and maybe not really noticing the other parts of this cat right here. So I'll just show a few others. So we got another example of this bird where a student said blueberry, right? And I think it's kind of, again, could be experience based. Has this kid with CVI had a lot of visual access to bluebirds? Maybe not, or birds in general for that matter. Maybe they've had more access to blueberries if that's something that they're used to eating, right? So experience based, but also I think it's a good example of color and gross form, and over relying on those things, maybe because salient features are still difficult for that child. What about the error patterns here? All right, so this student looked at this bed, this abstract color illustration of a bed, and said dinosaur. Does anybody else see the dinosaur face here, or what could be interpreted as a dinosaur face, right? Does anybody see, like, this is how, after he said dinosaur, this is kind of how I pictured it. You've got these orange pillows with sort of like these could be eyes, right? And they've got these little black wisps on top of them that could be like either, I was going to say eyebrows, but I don't think many like dinosaurs had eyebrows, but maybe like the little, how sometimes in illustrations, the top of the eye socket would be sort of illustrated by a line like that. And then you've got sort of this, the bed part itself almost looks like maybe the snout or mouth of a dinosaur. And this opening right here could be the mouth, or maybe the bottom of this sheet could be teeth. It's so interesting. The side here could be like the side of the jaw. But I just found this fascinating to see this student's not, they're seeing it. It's not like, the team might think, oh, the student might be blind, and not seeing it at all. They're seeing it, right? And they're seeing these features, but they're just imagining something different out of these features, possibly based on experience, but also because it's just so abstract. A student looking at this bed, what I think is a realistic line drawing of a bed, relatively realistic, and said teeth. Right? I think that's brilliant, so creative, so fascinating, and to me just shows like just like the creativity of this child. Teeth, right? And to me again, they're seeing maybe like one feature or one set of features, which could be like either the headboard or the footboard, and seeing how it could look like teeth. If you look at the headboard, you got the pillow there. That could maybe be the tongue. I'm just noticing that, and these maybe are shorter because the pillow is blocking part of them, so that could look even more like teeth, maybe. So to me, that was another example of single feature, but sort of making a guess, maybe not seeing the rest of the item.
Matt, someone had a student say piano for that one, for the bed.
Oh, piano. Oh, awesome. Yeah, piano, right? So like seeing those as piano keys, I'm thinking, yeah, possibly. Or maybe the gross form looked like the shape of their piano, like a grand piano or something. But to me, like my first guess into that, if I couldn't ask the student directly, maybe like point to the keys or where's the keys or where, things like that, I would maybe assume that they were thinking that the slots in the headboard or footboard could be keys or a keyboard. Did the person who said that, were you able to get additional insight from your student on which part he was thinking of as piano? If you think of it, or if there is, definitely just interrupt me and let me know, because that's really interesting.
She said yes.
Mhm.
Headboard looks like hands and feet of
No,
dinosaurs.
that was a different response.
Oh.
Sorry.
Headboard looks like hands and feet of dinosaur?
If he was only interpreting that portion of the picture. Was
Oh
that
yeah,
already-
I could see that. Right, like you almost got almost like an apatosaurus or a one of those other longosaurus things, like not a brachiosaurus. I don't know. But yeah, like almost like a really long tail. Then you got like some feet here, and then you've got like the body, then the long neck. I could see that too. I never saw that before. That's so fascinating. Very interesting. Teeth. Okay. So let's do this one together. So one of my, or I don't think it was one of my students actually. It was one of my Perkins participant students. When they saw this picture, said buttons. What do we think about this one? We think like gross form or single features. What features do you think are the buttons?
Single feature, and somebody said the wheels.
Yeah, that's how I see it too. Um, yeah, pretty amazing. I love that one. And I think that would be, it's always like, I really love, Dr. Roman Lansky's like, the comparative language approach where you get to, cause I think, I don't know, I'd like to think that hopefully I'd be honoring what the student was saying, but I think she really taught me that is that, instead of saying, oh, close, not quite, when a student says buttons, I would say, oh my gosh, I could see, where they point to the buttons, and maybe they point to the two wheels, and I say, oh yeah, I could see how those look like buttons, and maybe we look at some pictures on Google Images of buttons and talk about why they look like buttons, but then look at pictures of tires on Google Images and say, well, this might also be another way to draw a tire. Let's look at some other features of this object. Did you notice this part? What's this? Is it a door? And just sort of like honoring where they're starting from and then expanding from there. I think this might be the last one. This was a straw. And for this one, I could either see it two ways. I could see how the bristles, the way they sort of look like tubes, maybe the student was only seeing one or two of them and thought they were straws. But then the other possibility could be someone pointed out that once that this sort of looks like a long kind of, like those straws you get in like what do they call them, McDonald's? Like, those, like the milkshakes and stuff, Blizzards or something, or Frosties, where you've got like that kind of like, square rectangular sort of straw. Maybe they were thinking something like that, or maybe an adaptive straw that they were familiar with. So I think another example possibly of either gross form, if it's the whole thing, or a single feature more isolated if they were just seeing one of the tubes. All right. So what's the deal with this whole is it cake thing? Why did I start off with that? Well, I'm going to read a couple pages of text from the CVI Perspectives blog, because I just love this analogy of the show Is It Cake, and how this person, how Nye uses it to describe their experience with visual agnosia. So Nye writes that all of the judges have perfect visual acuity and neurotypical visual ability, and yet they are still fooled by the bakers more often than not. The winner of the show fools the judges, even though the judges change with each round, every single time. What this show reveals is that all people have an upper limit when it comes to visual object identification. Visual object identification doesn't only break down in times of stress, it can also break down under ordinary circumstances. Seeing is always a neurological process. The brain is always trying to latch on to various details to try to determine if an object is an object. And who would have thought that playing around with this process in visual neurotypicals could be a huge source of entertainment? I have to admit, as a CVIer, I am highly amused by sighted people being fooled by their vision, especially when they are so sure of what they are seeing, and then they still turn out to be wrong. On a more serious note, Nye writes, this show serves as an insight into visual agnosia. Visual agnosia is basically the same breakdown happening, except that in CVI, the ceiling of capacity is much lower. In CVI, the distinctions are much more rudimentary, such as being able to tell apart one's wife from a hat. I think, Nye's talking about referring to Oliver Sacks's famous example of the man who developed object agnosia from an injury to his ventral stream and mistook his wife for a hat. It's a famous book by Oliver Sacks. In this show, they are often splitting fine hairs, such as saying that a color is slightly too light or too dark, or that the curvature is not exactly right, or that the texture looks a bit off, and that is what gives it away in cases where the cake does not pass. But they are failing at the same process on a more refined and detailed level that CVIers often fail at on a basic day-to-day level. And then this is the last part. But despite the differences in severity, the experience of not being sure of what you are looking at and not being able to trust your visual perception is the same. For those who have not seen it, I highly encourage you to watch it and to follow along with the judges to even just get an inkling of insight into visual agnosia. So I love that example of kind of using an example of how, I like to often use examples of how even us, those of us who don't have a visual impairment, we still have our own thresholds for complexity of array, right? For how much simultaneous visual information we can handle at once. And I think this is a cake example is a nice analogy to think about how we also all have our own thresholds for object recognition. It's just that we usually don't encounter challenges to that ability on a day-to-day basis. Okay, so what is the app? So this whole 2D image assessment kind of like trying to assess what our students may or may not be seeing and interpreting. What might be the applications for instructional materials? All right, so let's take Aiden, for example. This is when he was in early phase 3. He scored 92% on color photographs, 85% on realistic color, and then his scores went down to between 54 and 69% when it came to abstract color, realistic black and white, and abstract black and white. So what did this say for his instructional materials? Well, it really had a lot of bearing on his accommodations page on his IEP. Because what we were able to say then for instructional materials is that color photographs and realistic illustrations are best, and those went in the IEP as an accommodation for all classwork. Another thing that we took from this was that for Aiden, color is more important, right? If an image was in color, it was easier for Aiden. But for Aiden, the level of realism seems to be even more important of a factor for him. So like, if it was realistic, but if it was black and white, he did better if at least it was realistic, right? So both realism and color seem to be important for him. And then finally, we were able to say to the team, abstract color images, realistic black and white line drawings, and abstract black and white line drawings are at Aiden's frustrational level right now. And this means that they are not appropriate visual learning media. Now, this doesn't mean that I wouldn't use black and white images in really scaffolded, supported games and activities to help teach him salient features, but it would be in a way where I was meeting him where he was at visually and giving him the support that he needed. What it meant is that when it came time to give Aiden a worksheet or to do a read aloud in a book with the class or to pick a leveled reader for Aiden to read, that we couldn't just give him stuff that he had never seen before that was in abstract black and white line drawings or that had abstract color drawings in it without either completely modifying the work or, if it was appropriate, giving him the right level of pre-teaching so that he knew what he was looking at when the time came. Okay, so that's just a little bit. There could be a whole presentation on what it means for, like different examples of modified materials for him and things like that. But I've kind of done that before, and I want to get into sooner than later some examples of teaching salient features. So I'm kind of just going quickly through that for now. And then I will have one slide on this too. What might be the implications for AAC? And the short answer is, I don't know, because I think it depends on each student. But the reason I put this slide in here is because I think in some ways AAC is different than classwork, right? In classwork, you know, when we're talking about worksheets and class read alouds and things like that, we're usually talking about novel materials that the student hasn't seen before, right? And when I give the 2D image assessment to students, it's really assessing their ability to interpret novel materials, right? But what about in a communication device where a student might have had the same images and the same pattern for months and months and months, and they've been practicing them, ideally, hopefully, over and over with enough support and within meaningful, motivating contexts of communication, well, then maybe some of those types of images that a student might not just guess right away the first time they see them, some students might still have the capability of getting them down pretty well after they've seen them a few times and got to know what they're for. So in the past, I used to do this, and I've seen other people do it too. And that's fine. I think people should be free to interpret this in whatever way they think is best for the student. But I would just say that I know that in the past, I've actually, I think, you know, over applied this when it came to some of my students' AAC devices. And then looking back, I realized that maybe it was too much of a, you know, too far of a reach or something, you know. And so basically, this is sort of like my caveat for this, is that the 2D image assessments that I do really only assess the student's ability to interpret novel images. You know, and then I talk about how in AAC, it's hopefully the images aren't novel, but they're practiced over and over again in that communication context. And then in AAC too, are we always looking for identification or detection of differences between images? And I have mixed feelings on this, and I think it depends on the student. And I'm not going to delve deep into that today, but I think that's another important consideration. You know, and then also, what about photograph? If we say that a student does better with photographs, what about when it comes to core vocabulary words like need and want, right? Does a certain student, you know, we could talk about the merits of having more of those or less of those on a particular student's communication system. But if we have more of the core vocabulary words, which are more abstract, how do we show them in images, right? And at that point, do we want to try words? You know, so I mean, I think it gets into a lot of these questions that come down to the individual student. And I just want to stress that with the 2D image assessment, I've gotten to the point where I apply it pretty strictly to coursework and class materials. But I just use it as one piece of visual information when it comes to collaborating with the family and the student and the speech pathologist around their AAC devices. Okay, so far I've showed you some examples of one way of assessing 2D image interpretation. But what about like most of my students, you know, who I don't give that assessment to because it's not appropriate? You know, either the images are just more outside of their visual experience, or maybe the student is nonverbal and communicates in other ways that wouldn't lend itself to that kind of assessment, or for a variety of other reasons. Maybe the student isn't quite at the 2D yet, and we're more thinking about what types of objects the student might be identifying. So I think the different ways we can assess this for students are as creative and diverse as our students are. You know, and like I say, I only use the 2D image assessment that I showed you with, you know, a small handful of my students. So what are some other ways to do it? Well, I think we can also, instead of assessing just identification by asking someone, what do you see? For a nonverbal child who can point and select a picture from a field, or who can give us a reliable yes or no response, we can go with recognition and ask them a series of questions about an image, or ask them to select the elephant from two images or four images, depending on their complexity of array abilities. So I think, you know, a lot of times I'll be assessing children like this, like using like the BitsBoard app and having them pick a named object from a field and things like that. What about using really familiar objects that are part of that student's routine, and we want to test whether they recognize them or not? So I had a student who was in early phase 2 at the time, and you know, the 2D image assessment wouldn't have been something that I would have given her. But what I was really curious about was, you know, for the objects right now that are in her daily life that we're encouraging her to look at and giving her opportunities to see, is she recognizing them yet based on their salient features, or is it more by things like context and color and stuff like that? One of the ways that we tested this for her was she had a pink water bottle, and her paraprofessional during snack time would have the pink water bottle in her hand and would bring it to the student's mouth and say, drink. Each time the student was ready to, well, each time it was like in between bites, and she wanted to see if the student wanted a sip. She would bring it maybe, a few inches from the student's mouth. As the student saw the cup coming, she would start leaning forward and forming her lips in that shape to take a straw. Well, I thought, maybe we can assess whether is she identifying this cup because it has a straw in a top to it, and it's got sort of the general shape of a cup, or is she going more by, this is the context of mealtime, and I know my cup is pink, and the person just said, take a sip. So all those things, how is she recognizing this cup? So what we decided to do was try taking her cup and a bunch of other pink objects that were similar sort of like shapes and sizes and stuff, toys and stuffed animals and things like that, and bringing them into other environments like the speech room where she didn't usually have her cup and stuff like that. And without saying anything, periodically we would just have the instructor pause the instruction and bring either one of the distractor objects up near her mouth without saying anything, or bring the cup up to her mouth without saying anything. And without fail, every time they brought like a pink lunchbox up to her mouth, a pink stuffed animal up to her mouth, she didn't really have any reaction. She didn't lean forward. She didn't put her lips in any particular position. But every time they brought the pink water bottle forward or the juice cup without saying anything, she would immediately lean forward and put her lips in that position. So that gave me some information that she's not just probably going by context and color, but that on some level she was recognizing the visual features of her cup and the features that distinguish it from other things in her life. Okay, one of the things I can also like to take a look at a lot, even if I'm not doing sort of this 2D image assessment that I showed examples of, is seeing to what extent might a student be over-relying on color instead of salient features when they look at something. And so this example is with a student who loves Barney. She can find her mom. When I was first interviewing her mom, when I first met her, her mom was like, let me tell you, she can find Barney anywhere. You just try to test her and she'll find Barney anywhere. And so it was true to an extent. Barney was like the thing that she had the easiest time visually locating in a lot of different situations, but her ability to do that, I found, was pretty fragile. So what I did first was I showed her 4 pictures of Barney, just like pictures on her desk, on paper. And one of the distractors was this picture of grapes that also had purple in it and also had green in it. And when I showed her just Barney and these grapes with 1 or 2 other distractors, she would always pick Barney. Okay, so I thought, all right, so even though there was another purple and green thing here, she was still finding Barney. Granted, the shade of purple is a little different, but I probably could have picked a more perfect distractor, but she was finding Barney instead of the grapes. So that told me to some extent she's going by some salient features, most likely. But then when I would take away purple Barney and I would introduce a picture of blue Barney that she wasn't familiar with, and I would show her the blue Barney picture alongside the purple grapes, she would always pick the purple grapes instead of Barney. And that just showed me, like, wow, she's over-relying on color still to identify Barney rather than the actual features of Barney. And I wanted to show this video of her. So this is a couple years after the Barney example that I just showed. It really kind of, let's see, I'm just going to hide the floating thing. And it really, to me, shows how far along her vision had come. Okay, so this is her on her touch chat device on her iPad, her touch chat app. And it's not anything, the display that I'm going to show you and that I was showing her is not anything that she was familiar with. I created it that morning while she was in other activities, and this was her first time seeing it. 2 years before this, when I was giving her the 4 Barney pictures or the 2 Barney pictures, 4 was the threshold of the amount of pictures she could handle before she just couldn't find what she was looking for. Now look what she's doing here. But look how important color can still be for her.
Okay, can you touch Barney?
Okay, so I'm asking her to touch Barney, and when she touches it, the I Love You, You Love Me song starts playing. And if you notice here on this screen, there's, let's see, 5 by 5. So there's 25 icons on this screen now. She's up to that. And I've got about 4 or 5 other purple distractors in there, along with a ton of other objects. And she's never seen this before. And I say, can you touch Barney?
Where'd Barney go?
There she goes. She's got it.
Nice job.
Here we go. So a couple seconds later, I moved Barney without showing her where I moved him. Still all those purple distractors. And I asked her now if she could find him.
Where'd Barney go? Can you touch Barney? He's hiding. Nice job.
Okay, so still no problem for her, right? But now watch when I show her only 4 black and white images on the screen at once, what her response is.
You touch Barney here, he'll play music. Yeah, Barney's gonna play a song if you find him.
Okay? So she pressed every picture except for Barney several times until she got frustrated. And by the time she found Barney, she was already so frustrated that she was unable to really wait and hear the music and had to just press the home button because she was trying to get out of that activity. So that just hit home to me as just an example of, and I was able to show that to her team and say, look at how good she's gotten at complexity of array when there's familiar colored image that she's looking for. But as soon as you go to black and white, look how difficult it still is for her. Okay. And so I think in addition to these types of, these are just a couple examples of sort of alternate ways that I've assessed this. But I think incorporating objects and images and noticing our students' responses over time, kind of like diagnostic teaching, in the form of our students' calendar systems, our students' experience stories, recipes, conversation boxes, all these things, using objects at first, then maybe taking photos of the objects, seeing if they have the same reaction, pairing them with the objects to teach them as they go through it, and then maybe in some cases gradually removing the objects if the student seems to be really understanding the image as well, or staying with the objects is fine too. But I think it's just that I often will give my students that opportunity to see the photograph of the object next to it within meaningful context over and over, and then sometimes the student ends up transitioning into understanding what those images mean. All right, and then what about alternate assessment for students who do take the original 2D image assessment that I showed and just blow through it and master it? They ace it. That happens with a lot of students that I see, especially those in phase 3, especially those in mid to late phase 3, just kind of often just blow right through it and have no trouble with it. Well, does that mean that they don't have difficulty with any types of objects? Not at all. I mean, I like to stress that this 2D image assessment shows very, very basic isolated images. And just to make sure everybody's thinking of this too, is that I'm totally aware that it doesn't assess complexity of array at all. And the reason for that is that I use other things to assess complexity of array, one of which is the CVI complexity cards from APH. But with this assessment, I wanted to go for mostly just things that were isolated, just to try to isolate that ventral stream object or image recognition. And so anyway, but one of the things that I do if a student just kind of aces the first version of the assessment is I show them really weird pictures that kind of conflict, where the surface pattern of the thing or the context of the thing heavily conflicts with the salient features. Because what I want to see is, if the student aced the first 2D image assessment, then that tells me that they're using salient features to some extent pretty well. But how fragile is that still, right? So I'll show them images where the surface or color pattern highly conflicts with the salient features, because I'm asking myself the question, is this student's sense of salient features so robust and so unshakable that it can withstand these contradictions in context or color and surface pattern, right? So I had a lot of kids call this a dog right away, but I've had others who have aced the other 2D images say tiger. And that tells me that they're right now, their salient features can only take them so far and that we still need to practice it. I'll show students like this, and they'll say cow sometimes. Others will say fish, and that gives me a lot of information about sort of the extent to which their salient features will prevail in these situations. Because the real world's complex, and I try to introduce this level of confusion or complexity to see how far salient features can take them. And then, I've had some students call this an elephant right away, and that tells me a lot about their ability to, sort of use salient features, even when color conflicts. And then I had lots of students, even in phase 3, call it an elephant. Call it a zebra still. Context. So to what extent are some of our students maybe using the context of something to correctly answer what it is? So when I show this picture to students of an elephant sitting in a tree and they say elephant right away, again, that gives me an idea that, all right, their concept of salient features, at least in this case, was robust enough to withstand the different context. And that they're, and then for this, same thing, context versus salient features. Is this a dog because it's a man walking a smaller animal in a street, which is what we expect from context? Or do we notice the horns and the hooves, and our sense of that salient features overrides the context and lets us know that it's not a dog?
Matt?
And yeah.
So we're curious where you find some of these photos.
Oh yeah, right.
Yeah.
I don't know what. So Google Images. It's all Google Images. Like it's so funny. If you type in dog with tiger stripes, this is only one of like 10 images. Where do people find the time to do this? And you imagine, like, where does these things come from? I just type in cow pattern fish and one comes up. I type in zebra elephant and like 7 come up. It's so funny. Elephant and tree. Yep, here's a bunch of pictures of elephants photoshopped into a tree. So that's the funny thing to me, is that like almost anything I can think of, I type it into Google Images and boop, there it is. So it's just, I don't know, I love it. But yeah, that's where I found all these images. And so really, you feel free to use any of these when you assess your students. I'll leave the slideshow in the handouts folder. But also feel free to do any, like, so if you have a student who does really well with trucks or something, maybe just try finding weird pictures of trucks in unusual contexts on Google Images and see if they're still able to use the salient features. Okay. Is it cake? What do you think? Yes or no? Cake or not? Cake or the real thing?
We're thinking no.
Not cake?
No. And then yes, we got, is it real? Yes. And then a couple of no's.
Okay. The answer is, it is real shoes.
Real shoes.
Real
Okay.
shoes. It's not cake. But yeah, interesting, right? I think the platter sometimes can make people second guess too. But anyway, so I want to say about the 2D image assessment, because I've seen it over applied before, and it kind of distresses me a little bit, because it was one of those things. I was doing a lot of assessment with my students in this. I was excited about it when I wrote the chapter for Christine's book, and I put it in there. And I just had no idea that, I guess I should have thought, I just foresaw something like that coming, is that a lot of times people use it, most of the time people I think use it appropriately, but I've seen cases where it's just used in inappropriate ways. Like I've heard from people, even ones that I work with, in Connecticut, saying, oh, well, I went out, because the parents think this student might have CDI, and I went out for a consult to see if give them more information while they refer them to an eye doctor. And we want to give the eye doctor more information, but I'll see they'll say something like, I used the 2D image assessment and they got them all right. So I said to the family, nah, that doesn't really look like CVI to me. I'm not seeing it. And like, oh my God, you know what I mean? Like, I want to just like, I have so many students with CVI over the years who just ace it and have no problem with it at all. And even when I show them the tiger stripes dogs and the weird things, still ace it. But through months of getting to know the student and the family and more observations and more assessment, like eventually the fuller extent of their CVI and how it's impacting them comes out really obviously. And so anyway, I just want to give these caveats that I really had no intentions for this assessment other than as one useful tool for a small portion of the population of kids with CVI. And then really for others, I modify it and make individualized ways to try to figure this out. And I just want to give this, this part right here is just that, I always tell this to teams if their students have difficulty with 2D image interpretation, because I don't want them to see that difficulty with image interpretation and assume that it's because the child has a cognitive issue, right? Because if you see a 7th grader look at a rhinoceros and say it's an elephant, people who don't know about CVI might think, oh, okay, it must be some sort of cognitive issue. But I just want to share this story of a student who I had when she was in 4th grade. She's going into 11th grade now. But when she was in 4th grade, she had done an 18-page handwritten paper on rhinoceroses and about like their habitats and where they live and how they care for their young. and all this stuff. And she was sharing the information with me after she got her paper back. She got a good grade on it and a sticker. She was really proud of herself. And she taught me a ton of things I didn't know about rhinoceroses. And then we did other stuff in our sessions. We worked on our goals and objectives. At the end of the session, just out of curiosity, I pulled out Google Images on my iPad, pulled up rhinoceros, this picture right here. And I said, oh, hey, before you go, do you want to tell me what this is? And she looked at it and kind of thought about it and said, well, I think it's an elephant, some kind of elephant, she said. And I said, well, what makes you say elephant? And she said, well, it's got a gray trunk, and this has a gray, she said, elephants have a gray trunk, and this has a gray trunk, and she pointed to the front leg. And so here was an example of a student who had mastered, for her 4th grade level, had mastered rhinoceroses as much as any 4th grader could have, right? And she knew more about them than I did. From a cognitive standpoint, she had rhinoceroses down, but from a visual perceptual standpoint, it was difficult for her still. So I use this as an example to really stress to the teams that, we don't, not only do we not want to assume that a student is cognitively impaired because they get this wrong, but we also don't want to assume that if just because a student knows a lot about rhinoceroses or any other topic, we don't want to assume that therefore they'll be able to interpret any sorts of images or pictures that they see of that topic. So I think it goes both ways, and we don't want to confuse the two. All right, so what about instruction and salient features? This is really all. I don't think I can add really anything to the discussion on salient features from what Dr. Roman has taught us, besides giving some examples of how I've applied that with a couple of my students. So that's what I want to do here. So, and kind of like when I give the 2D image assessment, more often than not, I also use it as a way to figure out where I'm starting with salient features instruction. So in this case, Aiden had difficulty with certain types of drawings, and I noticed that when it came to the actual items, he really struggled with sync and he really struggled with computer more so than some of the other items. And, these are all items that he encounters in his school on a regular basis. And if the overall goal is that I want him to be able to look at his classroom and understand what his surroundings are better, then I wanted to work on some of these things that are everyday items in his environments throughout the school day. So I picked sync and computer to start with. And so going based off of sort of a lesson sequence, based off of what I learned from Dr. Roman Lancy at that first boot camp, I would basically go through this sequence where first thing that I should probably read it. The first is like the scavenger hunt model, right? But before I do that, I would show the person this was Aiden, like a real version of a thing, like a real laptop, right? And he would touch the touch screen. He would touch the keyboard. We'd talk about how this screen looks different than his iPad screen. And then we'd go to the desktop at his teacher's desk and say, this is a computer too, but it doesn't fold up. Where's the screen on this computer and how is it different? And where's the keyboard at this computer? Is it bigger or smaller? Is it attached or not attached? We kind of go over that in a kind of fun sort of way. And then after that, we would actually, like take a picture of it, or look at pictures of like realistic pictures of those things, of computers, of syncs, and use an app like UDoodle to highlight or place one of those fun stamps that make sound on it on the UDoodle app. Actually highlight or place a stamp on those features on the real objects. Then we do the same thing for like black and white versions of those objects. I might show them a realistic photo of a computer and say, let's put that smiley face stamp on the keyboard. And so he'd do that. And then maybe I'd show him a black and white line drawing and say, where's the keyboard on this one? This one's weird. It doesn't have color. It's a line drawing of a computer, but I bet we can still find the keyboard if we look for those same features. Let's put that stamp on the keyboard, and then we would expand and we would do a scavenger hunt throughout the school to see if he could find computers and syncs in other rooms throughout the school. And he would have his iPad with him and he would help me take a picture of each thing that he found as sort of like gathering up the things that he found on his scavenger hunt. And we'd then go back to the room and he would import his own pictures that he took into UDoodle and he would highlight the salient features on them. So we had a lot of fun with it. I think that's the most important thing, making it meaningful, making it fun. Because man, if I were to he has a hard time with this. So if I were to just drill him on salient features sort of out of the real world context, I think it would be super boring for him. And I don't know if he would learn that much. So again, showing him lots of different pictures, different variations of sync and computer. And again, this is all from Dr. Roman Lancy's work, but this is just an example of how I've used it with Aiden. Okay. And I'll just show some examples here. So these were two pictures that Aiden took himself with the iPad. I would hold the iPad study once he pointed to the thing that he found, and then he would take the picture. We would go back to the, he would press the white button. We'd go back to his classroom, pull up our pictures in Doodle Buddy, and he would then highlight the different salient features. And he got to choose his colors, which he liked. So I just want to say two apps that I often use to help with salient feature instructions are Bitsboard, and that can be good for assessment too. Like you can make your own flashcard games on the iPad, and you can import any images that you want on them. And then you could also, I also use UDoodle a lot for not only assessing, but also teaching in a lot of like fun ways, salient features to students.
Matt,
Yeah.
I just wanted to give you a friendly prompt. That
Oh
is
yeah, yeah.
almost 3:30, but whenever
Perfect.
you feel like it's a natural break, feel free.
Perfect. Thank you so much. I would have lost track. Yeah, and a couple more slides. Let's do it. Well, in a couple more slides. So this is so looking at Aiden's progress in this over the years, his ability to identify. So every couple years or every year, I would re-administer the 2D image assessment to him, the same one that I'd given him since the first time. And since I never told him whether he was right or wrong, and even though we worked on salient features, I never showed him those exact pictures again until the next assessment. I feel that there's some, educational validity to that, and that I don't think he was really memorizing the pictures or that they were that familiar to him. So anyway, just interesting progress. So like you see here, his progress from October of 2015 to March of 2016, he got better in identifying all the categories, right? Color photos were always still easier, but he went up in all the categories, and he continued to increase from March to February of 2017. So another year, he increased even further. And the interesting thing about this was that we had actually moved on to other sets of, between March of 2016 and February 2017, we had moved on to other types of images other than that set that he was originally working on, like other items, not sinks, not computers, just other things like animals and stuff. But he was still continuing to show progress in those areas that he had struggled with. And then this past spring, I actually made a different kind of graph showing his progress in each of these categories from 2015, which is blue, to 2021, which is red, and just like such encouraging, amazing progress. He went up in all the areas, and he's at 90% with the items that he initially had the most trouble with. And it's interesting because this time in 2021, I actually gave him a brand new 2D image assessment that he hadn't seen before. So it was even all images he had never seen before, and he still did better in all the categories. Now, I don't want to use this to say that I know that those interventions that I did were the things that directly caused this. As a teacher, I feel like they played a big part. Like as a teacher, watching him grow over the years and having not just me, but also many of his other team members reinforce salient features and do really great thorough picture walks before he read any book. Like if you add all that up from kindergarten through now, he's going into high school, I do believe that it played a role, but I want to stop short of saying, oh yeah, this data proves that my instruction made all that difference. It also could be just visual development in general. I mean, there's other things that he's developed in visually that I hadn't been explicitly teaching that he's just gotten better at. But I'd like to think it's probably a combination of the two. His visual system maturing a little bit in general, but then also I think this really targeted specific instruction and frequent opportunities to have access and to practice 2D images that were at his level. And when they were beyond his level, it was supported in a way where he could get there. And I think like Christine Roman often says, it's like you're teaching, it's like you hope that you don't have to teach every image that the student's ever going to encounter, because it's not that you're teaching them to memorize certain images. I think the hope is, like she says, is that you're giving them a metacognitive model to follow, in realizing that even if they don't know what a picture is at first, some of the same strategies they use to identify another one might apply to this one, even though it's a different thing. So, okay. All right. So why don't we pause there and take a 5-minute break? Let's see. I'm just checking it's 3:32 now. So could we come back at 3:37? Let's do that. Thank you, everybody.
Thank you, Matt.
You're welcome. And if you are hanging out during the break and you have any questions, feel free to just speak up, because I'll be sticking around. I know if we were in person, it would be like, that'd be kind of a natural thing to do, but feels a little different when it's virtual. But yeah, I'm here, so feel free to bring anything up or ask any questions.
Matt, we do have a question.
Oh, sure.
Do you have any general tips or resources for working with students with, oh, sweetheart, hominis hemo?
Oh, homonymous hemianopia?
Yes.
Yeah. Yeah, I mean, homonymous hemianopia is it's really,
It's
homonymous
hemianopia.
homonymous hemianopia. Okay, thank you. I mean, I think, yeah, because I don't talk a lot about visual fields here, but it's certainly so important. It's like, regardless of what issues a student has with complexity and these other characteristics, we have to know before we think of any of that, which fields that they're seeing out of. I mean, so I think that's always a first important consideration when we're thinking of that. I mean, I think of homonymous hemianopia as really just that field loss that can come with CVI. If the right side of your occipital lobe has the damage, then you're going to have that hemianopia on your left, and vice versa. And that most of our students or I shouldn't say most, but many students with CVI have that issue in the lower field. But I mean, strategies, I think do you mean strategies as far as like how to try to ensure things are placed in their better field, or strategies as far as how to like try to encourage development of the other field? Well, because I asked that because I think like I've seen, so I have one student who she had her right occipital lobe completely resected surgically to control seizures when she was really young. And so when she was really young, she had basically no left visual field. And then, but it's interesting because if you look at her eye reports from the time she was like 5 or 6 up until now as a teenager, her left visual field has slowly come back, a lot of it. And it seems to be, I was talking to a neurologist about this, and the thought is that, like we've heard with CVI, is that it seems that other areas of her brain, possibly even areas that are responsible for, other visual aspects, have actually taken over potentially for that field a little bit. So I think there's always that question of, if we put motivating, interesting things and encourage that child to use that impaired field or that non-preferred field, will they eventually start to use it a little bit more, and will it open up a little bit? And I don't know for sure. I think it depends on each kid. I've seen students where it's opened up, and then I've seen others where it stayed kind of the same throughout their childhood. So I think, oh, I think somebody needs to mute.
3-hour class.
Just make sure everybody's on mute.
Yeah.
Okay, thanks. All right. But then I think also, when it comes to, I think all of these strategies like that I'll be showing, like when it comes to math and things like that and images and everything, I think we always want to make sure first that it's in the correct visual field. I think the thing that I have one student who he can see out of both fields, but it's a lot harder for him to process things in his right field. So whenever we modify print material for him, it's always to the left side of the page, like a newspaper column, and he prefers things that way. So I think there's a lot of potential strategies depending on the student of ways we can like kind of rearrange things to try to keep it on that better field. But then also depending on the child and depending on that goal when it comes to vision, if there is that desire of the family and child and team to try to like encourage vision in that other field, are there certain ways that we can play games and do fun, motivating things for the child where we're kind of putting things just into that other field a little bit, and seeing if they can expand their use of it. Sandy, I see you have your hand up.
Yes, I do have my hand up. Can you hear me?
Yeah.
I had a kid recently who was a high school student who had that condition, which shall go unnamed right this second. But the problem for him was it was right. And if it's a right hemianopsia, it is much worse than if it's left, because we read left to right.
Oh, yeah.
And so as he's looking, our macula, fovea, whatever, previews the next like 10 or 11 letters, and we're not even aware that that's happening as our eyes going that direction. But he only got a few of the letters as he's trying to read. So he looks at the first few letters and makes a guess as to what the word might be. And he's come up with a lot of strategies, but it's a very different thing if it's right versus left, because the right really, when I researched it, has a huge impact on reading. He was very bright, but very slow reader, very, he said, I would sit and take a test and they give me a paragraph to read and then I'm supposed to answer questions. He's like, well, if I take all the time to read the paragraph, I'm not good. I'll be gone by then, right?
Yeah.
And I can't do it. And he said, so what I'll do is I'll go look at the question and get keywords and go back up and try to scan for those keywords and see if I get the answer to the question. And that's one of his coping. So he's found a lot of coping strategies. He really needed his teachers to understand why he is exhausted. And his mother, because I said to him one day, oh my God, you just have to be exhausted at the end of the day. Would come home and do all this homework too. And he said, yeah, and could you please tell my mom that? Because, she just really wanted him to get everything. But a right hemianopsia, homonymous hemianopsia is much more difficult for our readers.
That's such a thanks for bringing that up, Sandy. That makes me think about my student too, because even when it's in the left, he can read it and he can read really small font. He can read really quickly, but he gets tired really quickly and he gets like really overwhelmed by it. How's your student's auditory? Like, does he access when he gets tired? Does he ever switch to auditory or?
Well, he said the only way the auditory works, because he's got he also is diagnosed with dyslexia and dysgraphia, and his auditory, processing's okay. He says if he just listens, his mind goes wherever. But if he can have it in print, and computers don't work for him, they make him really tired. If he can have it in print as well as listening and follow along, then that's what he needs to attend to the auditory component. So
can I make a suggestion? If you have if you cordon off just a line of letters, like with a typoscope, and put it vertically to do it, because then he's not moving, left to right, he's moving, up and down.
I did read that suggestion of turning the page, 90 degrees.
Not the whole page, because the figure ground demand is going to be a little bit much, but if you can cordon it off with, a typoscope type of thing and just isolate a line,
Yeah, that
and
was,
then he can,
he was willing to do.
okay. The other thing
That's-
is
that's
that kind
cool.
of kid may wind up having to be a head scanner, and you do have to underline the sentence and only have him use that sentence. He may be okay with the lines above it, but to underline it, you know, with like a card or something, so that he can, you know, see where it starts and then scan with his head across the field, so that that
Yeah.
homonymous hemianopsis keeps moving.
Yeah, he had figured out a bunch of strategies, and he is on grade level and taking all these honors classes and really worked, but he is working so hard to keep up at that level. But that's what that is the goal he has for himself,
Mhm.
is to really do grade level stuff and to really, you know, so he's in honors history and in honors math is a hard thing for him. But he can do it. And, you know, just, I think even for himself, understanding why it was so much effort and he's not being lazy or giving up or whatever. I think part of what I did, it was a short-term consult. And part of what I did in all my meetings with him was really help him understand what was
Mhm.
going on with vision and why it was so hard and what kind of accommodations, because he was, you know, 16 in his own IEP meeting, you know, it was, because I talked about using voice to text when he has trouble writing, because he also has CP, mild CP, he
Mhm.
walks and does, I mean, he coaches soccer, he pushes himself
Wow.
relentlessly. But he says, when I go in the gym, I have to do extra scanning to the right to make sure I'm not going to run into, I mean, he's always, he knows, but he's having to work so hard to do that. And I
Mhm.
think it was just affirming for him, for somebody to acknowledge how much extra effort is being put into him doing what he does.
Yeah. That's
It
a-
Hey,
was
Matt,
amazing, Stu.
so it's
Um,
3:44, but this is a excellent conversation.
yeah,
It's
yeah.
totally up to you. We have
I s-
another person with a hand raised, and then Diana made some more comments about this topic, so.
Okay.
uh,
That's great. I say we continue the topic because I can always readjust. You know, this is great. Well,
Okay,
because I just learned a lot from Beth and Sandy. You know what I mean? I mean, this
yeah,
is like good to all
I
be sharing
agree.
and stuff.
Yeah, I totally
Um,
agree. Do you want me to read Diana's comment?
sure.
She was the one that asked the original question that brought us to where we are today. So she wanted to just follow up and say that the doctors made it seem like it was impossible for, I guess, the vision to return. So I'm always debating between, do I present things in the better field or try to encourage vision in the other field? She's a preschooler, so it is left side for her. She has trouble finding the next line of letters, images in a row. So what seems to help her is a sticky note at the start of the line.
Ooh.
And then Deb said the voice dream reader app may be helpful for,
Mm.
I think she's talking about Sandy's student. And then we had another participant say, or ask maybe, does he, meaning probably Sandy's student, does he do better with digital books and backlit? The size and
No.
spacing can be used
No,
manipulated to reduce clutter, especially with a touchscreen.
no, he was absolutely adamant that the computer was fatiguing for him.
Yeah, yeah. And so now
Mhm.
Mara has her hand raised as well.
Okay.
Hi, sorry, let me
Hi.
lower my hand. I have a son who was we discovered he had CVI as well as left homonymous hemopsia at 17. I have a simple question, I think, because I think I know what head scanning is, but I am not sure if someone can just explain that briefly. I think it's just moving his head instead of his eyes, but I want to make sure that I'm not missing anything for him. So thank you.
Thank you, Mara. Yeah. Does someone
Yes,
else
it
want to
is scanning
speak to
with
that?
the head and not moving the eyes.
Mhm.
Thank
And
you.
yeah, Mara, how is he doing with reading right now? Like, what's been working the best for him?
For my son, he actually is a fairly fluent reader when he's got enough energy. So he can read at like 8th grade level. For him, it's really comprehension. And that's, I mean, that's basically at a 2nd grade level at best.
Yeah.
And I think that has a lot to do with concept development and a lack of experiential learning and things
Yeah.
like that. So, but he also plays the piano beautifully. He doesn't, he can't read music at the level that he can play, but I'm hoping this it's hard to use your head when you're playing the piano. So we use his music in a positioning to position it. But when he plays more complex music, you don't have enough room on the piano. So
Uh-huh.
that's why I was interested in the head scanning, if it was
Wow,
simply
yeah.
in his head.
My student plays the cello, I think, in band, and he can't really read the music because, again, you're going into your blind field.
Mhm.
So he basically works really hard and memorizes the music.
Yeah, that's what my
is
son does. Yeah,
Yeah.
he's one of these, that's how we knew, we kept telling, my son has autism too. And
Mhm.
oftentimes I think when you've got a kid who's got significant challenges associated with their autism, it masks everything and nobody else looks at anything else.
Yeah, yeah.
For years, we said he seems like he's functionally blind to us. We know, and I didn't know what CVI was. And then when his piano playing started, we're like, he's like those guys that are blind and have autism,
Wow.
that hear something once and can play it. Something's going on here. So he does rely a lot on his memory, but that's like his one skill that could very likely be something for employment. And they're telling us he
Mhm.
really needs to also learn to read music. And it's been quite a challenge for him, unfortunately.
So yeah. So like with the field loss and everything, are you saying too that is it mostly come in with reading music, or is it you're saying with the keys too? Some of the keys are outside of his visual field?
Oh, they're definitely, it's, I guess piano is so motivating for him. He
Mhm.
he doesn't look at the keys, so he can, they
Nice.
would be if he moved, when he moves his
Yeah.
hands to the left, but he doesn't look at his hands when he's playing. So, so it works for him
I
that
wonder
way.
why they're saying he needs to read music. I mean, in what sense? Like if he's going to go to college for it, or
Yeah, we're hoping maybe, there are a couple of, IDD programs that there are just a few that are music related. So,
uh-huh.
and they want him to read music, but, it's a challenge. It's definitely because he's like, I can just listen, and it's hard because
Yes.
once he's played it once reading the music, he's memorized it. So then he doesn't
Okay.
read the music. So,
So
so-
I'm wondering, so there's a person out there with autism and CDI who wrote a book about music. It's called Perfect Pitch in the Key of Autism. I just started reading it, so I don't know much about it yet. But if you,
Henny,
yeah, Henny Cooperstein.
yes.
If you email, so is that you, Mara? Have you heard of her?
I've heard of her and I've read the book. Susan Rancer wrote the book with her. And so I had
Okay.
it evaluated by Susan
Okay.
a long time ago, but I haven't gotten in touch with Penny, but I should probably reach out. So thank you.
Only wondering because there might be I think she knows a lot more about music too than I'd be able to, but it just seems like I know other musicians who are learning more auditorily and they've had trouble with their professors saying you got to read music. But so far, I know one in particular, if you email me, I can reach out to them and I'm sure they'd be happy to
Oh,
make
thank you.
contact with you. But maybe they're a vocalist, but maybe they could share some of their experience in college and everything.
Oh, thank you. I
Um,
really appreciate that. I
sure,
definitely
sure.
will.
I don't
Thank
know
you.
if my email is part of is sort of included in the presentation write up at all. But if anyone wants to email me after the presentations, it's Matthew, all lowercase, and then a period, and then my last name, all lowercase, at gmail.com. So yeah, anybody, just feel free to send me if you have any questions or follow-ups. I'd be happy to. But yeah, thank you everybody for kind of participating in the conversation. I think one of the questions in the chat, it was something like, should we present things in the preferred field or should we encourage the other field? I usually, for most of my students, will tell teams like, seeing is hard enough as it is for the student. The complexity of the environment, of the materials, all of it is so overwhelming enough, and there's so much visual fatigue that, like, at least if we know a student's better visual field and we're trying to get them to participate in a math activity or a literacy activity in a visually comfortable way, let's make sure we put it in their comfortable visual field. But depending on the student, if the family and the TDI, and if we decide that we want to encourage the use of that vision. But I mean, depending on a lot of things, I guess, in that other field, maybe we don't do that when they're doing a complex math activity or a reading activity, and we don't expect them maybe to see circle time from that reduced field. But maybe in maybe in some sort of like really highly motivating game that you're playing with them at their desk, or some really highly motivating, like it's snack time and you do a little game where let's search for the goldfish or something, and you search for one, then you hide one on me and I'll search for it, and that kind of thing. Maybe you start placing it in just slightly into that other field, and see if they can find it and look for it. And again, if I would say if it's causing the student any stress, then it might not be an appropriate thing to do, and we might want to revisit how we're doing it and whether it's motivating and whether it's worthwhile. But I think you can do both. I think you can put complex things that are hard for them in their better field, and then maybe for some kids use fun, encouraging things to see if you can encourage that use of the other field a little bit. Sandy.
Yeah, the last comment I'll make, this kid spent a lot of time in vision therapy, learning, some of the tracking things. He actually found that extremely fatiguing, but actually very helpful.
Cool.
In expanding some of how he could how he could track into that deficit, into that field. Didn't cure it, but, and
Right.
so at accommodations, but he's probably the only student I've ever had that did vision therapy that said it helped some. So I threw that
Yeah.
out.
Thank you, Sandy.
Vision therapy. Right?
No, thank you. Actually, that's really good, because I've had a couple of experiences like that too, and I've had others that were mixed. And it's like, but I think it's important to know that there's that possibility. You know what I mean? Like with some kids, and it depends. Yeah, totally. That's the same way. Like, speaking of things that are tricky to bring up, I would say too that even if someone has really good acuity and they're older and they're reading really well, like I have the student who I mentioned with I forget what I just said about him. It was because of the visual field loss. He reads really well, really small print, but he can only read for like 3 or 4 minutes at a time, and he has an auditory processing disorder. So recently his mom and I approached me like, can we start learning Braille? I'm like, absolutely. Let's give everything a shot. Like, why wouldn't we do that? And he's pumped about it. He sent me an email saying that for the first time, he's excited about his future. I don't know if it's going to work, but I hope it will, So I think it's one of those deals where, we just got to look at the individual student and what's going to work for them. And maybe multiple things will work for them. I had another student who was that I started with her in 3rd grade. And she was a dual media learner from kindergarten through 3rd grade, learning both print and Braille. She has CPI. And she was so funny. She would always try to sneak a look under the occluder, and she would read the Braille cells by sight and everything. And she just turned out, by 3rd grade, it was readily apparent that she was increasing as a print reader, and the Braille didn't really stick for her. So, and she reads really well now and uses auditory as a supplement for the print when she gets tired. But then I have this other student who he's read faster than she's read his whole life, but he expresses being so tired that he wants to try Braille. So I just think it's one of those things where it's like I'm always learning from my students,
Right, everything.
But, yeah. Okay, so let's see. I should get back. This is anytime anybody wants to start a discussion like this, please. That was great. Otherwise, I feel people are going to get tired of my voice. All right, let's see here. Do the image assessment. Okay, so we're almost done with this part. I just want to.
Hey, Matt, you're not sharing your screen anymore.
Oh, sorry. We've been talking for a while. I forgot that I never shared it again. Okay.
And then Sandy and Tracy, if you guys could minimize or could close your videos just so that we have just the interpreter and Matt visible. Thanks, guys.
Yeah. Thank you, guys.
Tracy, you came back on. I can close it for you if need be.
As I pull this up, I'm just going to, Mara brought up the topic of reading comprehension, and I have something I'm really hoping I get to share, like I'll have time to, tomorrow, about the concept of visualization for students with CVI, and possible difficulties using internal visual imagery and how that can impact math performance and reading comprehension. So anyway, it's just something I'm really been excited about learning about lately, and figuring out how I can maybe help some of my students, or at least understand them a little bit more. And I'm going to share some of that with you tomorrow, hopefully. Okay, current slide. Whoops. Why is it not? Weird. It's all of a sudden not going to. I'm just going to close out this PowerPoint real quick and open it back up. For some reason, it's not entering full screen mode. Can you all see my screen?
We see, now we do.
Okay, now I don't know why it wasn't going full screen. Let me try. Hopefully it'll. Oh yeah, now we got it. Okay, but I got to go to the right slide and get rid of this thing. Done. Okay. Here.
The
Yeah, so
bar is
basically,
still there.
I know. Every
Okay.
time I hit escape, it's going to show up, and then I just got to get rid of it again.
Okay, no problem.
All right. I wish there was like a permanent. Maybe there is a permanent way I can get rid of it, but okay. Slideshow, please work. Perfect. All right. So I want to share as we wrap up the whole discussion on like 2D images and salient features. I just want to share a set of goals and objectives samples from one of my students, and then show you one activity that I used with him to kind of meet some of these, practice some of these objectives. So these were 4 of the goals and objectives on this student's IEP, student in phase 3. And he was working on these things for visual search and salient features. So after reviewing the salient feature of an item and using a color-coded 4-quadrant overlay, student will search a photograph of a visual scene to locate an intended item. Using a color-coded 4-quadrant overlay, you'll see what that is in a minute, student will compare 2 photographs of almost identical visual scenes and identify 1 to 3 differences between the 2 scenes. Given images of 2 items that share some familiar features, student will use comparative language and describe the salient features that make the 2 items alike and different. And then finally, after reviewing the salient features of an item, using an imaginary 4-quadrant overlay, the student will search a visual scene and find the item. So the goal with the overlays is to help him learn how to break down a visual scene and search it one part at a time. And then eventually to without using the visual, kind of internalize and imagine that. And he's actually been able to do that really well. I'll show you what I mean. Okay, so my first rule with any of my students is I try to make it fun as much as I can. This student at the time really loved The Simpsons. And that was just like, we talked about The Simpsons a lot. We would joke about The Simpsons a lot. He had certain favorite characters. So we would create whole sort of PowerPoint adventures where we would be helping a character on The Simpsons locate certain things and find certain things. So it was usually Chief Wiggum. So it would start off with the student, with me saying something like, in Chief Wiggum's voice, something like, all right, Bobby, I need your help. Homer's guitar is missing, and he thinks someone might have stolen it. Can you help me find it? We would pretend we were talking on the phone or the CB with each other. And then this is a really truncated version of the lesson. I just used one, maybe 5 out of 30 slides, but just to show an example. I'm going to get my police car and drive to Evergreen Terrace, where the Simpsons live. Right now, I'm at the police station. Can you help me? All right, so just to work on mapping skills, a little bit, I'd say, okay, I'm at the police station. Help me find Evergreen Terrace. And over the Zoom, this was during COVID, the student would, or during the lockdown, the student would say, all right, drive straight. So I'd go straight. All right, Chief Wiggum's going straight. Where does Chief Wiggum go now? Chief Wiggum, turn left. He'd tell me. So I'd turn left, I'd go left. Where do I go now? So it's under Simpsons Street over there. So take a right, he'd tell me, and I'd take a right, and we just keep doing that until I got to he'd say, okay, you're there, park there. So I'd park there, and then I would hide the floating meeting controls. Okay, and then we'd move on, and we'd review the salient features of guitars and highlight them and things like that, acoustic guitar versus electric guitar, similarities and differences. And then eventually Chief Wiggum would call him on the CB and say, okay, great, we're at Evergreen Terrace. Here's a picture of it. And, here's the street that the Simpsons live on. And we'd talk a little bit about, can you find the Simpsons house? Do you see their pink car? Where's the street? And there's Chief Wiggum's car zooming in to the rescue. Thank you, Bobby. Let's see if we could find 2 guitars in this area. All right, so there's 2 guitars in this area. Can any of you find them? All right, and then if he had difficulty finding them at first, I'd say, you let me know if you want your police grid or if you don't want your police grid. And if he said, yes, I want the police grid, I would do this. And I'd say, all right, let's search quadrant 1 together, which he memorized was the blue quadrant. Let's search quadrant 2 together, which is the yellow. Let's search quadrant 3. He'd say, oh, there's a guitar. And, it's right next to the table, he would tell me. So then I would, oh, I wish this thing wouldn't do this. I would I'm just going to leave that there for a minute. I'll get rid of it in a sec. I would then take the guitar, move it out of the scene, and I would put it down into our, like, we had a little section where we'd be collecting all the guitars we found. I'd paste it in there. And when we found the 6 guitars that were missing, Chief Wiggum would say, "Wonderful, Bobby, I couldn't do it without you." And then we would make up some story where Chief Wiggum was now going to go and try to find more guitars. My student would teach him ahead of time what the salient features were. So then he'd say things like this: "Hey, Bobby, I'm calling again on the CB. I found an electric guitar. Here it is." And then he'd show something like this, and the student would laugh and say, "Chief Wiggum, that's not an electric guitar. That's a banjo." And then Chief Wiggum would say, "Oh, what do you mean? It looks like a guitar to me. It's got strings, doesn't it? It's got a neck, doesn't it?" And the student's like, "Yeah, but, you know." And so then the student and I would pause, and we would go through this. There'd be a picture of a banjo there. I don't know what happened. Oh, there we go. And then we would decide, okay, what do they both have? And he would tell me as I typed these in. Well, they both have necks. They both have a body. They both have a headstock. You know, this is like a little bit of a boxier version of Christine Roman's comparative language Venn diagram. It's the same, you know, that's where I got the idea. And then I'd say, okay, what does an electric guitar have? You say, well, an electric guitar has a plug, a cutaway, a pickup. So we go over all that again. What does a banjo have that a guitar doesn't? Well, it's got a circular body. It's got a drum head. And we'd talk about all those features. And then Chief Wiggum would call him back and say, "All right, you know, can you explain to me why they're different?" And then my student would explain to him why it looked like a guitar, but it wasn't ultimately a guitar. And then Chief Wiggum would keep looking. And then at the end, there'd be some kind of like, you know, "Thank you for teaching me about salient features. Thanks for finding my guitar." So anyway, you know, I think it's important just to try to make this fun and individualize salient features for each kid. And some people have asked me in the past, like, what about if a student's more working with objects and they don't have those same verbal abilities? How do you teach salient features? And you know, I don't have a like really good general answer for that, except that it's typically, to me, got to be with stuff that the student is familiar and motivated by. So this student loved going to Dunkin' Donuts with her mom on the weekend. So we had made an experience story where the box for the story was a Dunkin' Donuts box, like that you would put munchkins in. And then she had like a Dunkin' Donuts cup in there with a lid. She had napkins. She had a Dunkin' Donuts straws, sugar packets, all that stuff. And I even got a French vanilla coffee in the coffee cup and that's the flavor her mom drinks, and then dumped it out after letting it sit for a few hours so that the French vanilla smell would be in there, because she really loves to smell things in addition to touching them and looking at them and everything. So we had this experience story where it was, you know, that she goes to Dunkin' Donuts with her mom on Saturday, and we'd read the story, we'd give her the objects, we'd show her pictures on the iPad of those objects, but we would do things in the story like, "Oh, Mom got her coffee, but she can't find her lid. Where's the lid to the cup? Is the lid on?" And the student would look at and feel the cup and no, the lid's not here, right? Let's find the lid. So then the lid would be somewhere on the table, maybe next to other things, and the student would have to look for the round lid and find it, and we'd help her put the lid back on for her mom and then complete that part of the story. So that's just one little sliver of an example of like the ways that I try to brainstorm for different students. I'm like, how can we work on these things in a way that meets them right where they're at and is motivating? All right, and that's it for 2D image assessment. I'll go to the next thing now. But yeah, if you have any questions in the meantime, I'm just going to pull up the other slideshow. And next, I wanted to go into CVI and math. And I'll get rid of that in a sec. Okay, so this is, I wanted to, for like, this will probably take a lot of the time we have left today. It's already 4:06, so that's no big deal. We could always do the color section at the beginning of tomorrow. But I wanted to, one of the things I've really been excited to learn about lately and that I've been doing a lot of research and reading on is math and CVI. I feel like when it comes to literacy, there's already some stuff out there that has helped me a lot. You know, I think like, for example, like the what do you call it? The chapter on literacy and CVI advanced principles. There's a lot of great examples on Path to Literacy of different strategies that people have tried with their kids. There's, you know, a chapter in Vision in the Brain about some literacy accommodations and strategies. for kids with CVI. I think we still, I know there's so much more to learn in this area, but one of the things where I was really finding like really nothing that I could go by was on math, and how specifically CVI might impact math. And so that's something that over the past year or two, I've really done a lot of reading on and research on. And so I just want to share some of that with you. I have a presentation on YouTube and on Perkins CVI Now that's called CVI in the Math Mind, and it really goes really deep into this. I'm not gonna go that deep into it today for timing, but I want to show what I think is the most important introductory part to that, and really stress how at a really basic number sense level, CVI can have a huge role in impacting math development. Okay, so here we go. So I want to start off with, I'm going to be quoting a lot from the work of Stanislaus Dehaene. And he said I would say probably from what I found on university databases, research databases, he seems to be one of the leading authorities in the world on the neurology of mathematics. And he has a book that I'll show you in a minute that's really, really good about the topic. He says that a theory of education could only be derived from understanding the mind that is to be educated. And then Dr. Jo Boaler, I associate her a lot with the mathematics mindset and the whole idea that the growth mindset. There is no such thing as a math brain, you know. So even those of us who struggle with math, there's always neuroplasticity, and there's different ways and things you could do to increase math skills. All right, so let's do some math. I want to start off doing a little math. So you don't have to like call this out or write it, but I'm just going to sort of ask you these questions, pause for a couple seconds, and go to the next slide for the next few slides. So which quantity is greater, A or B? It's pretty easy to tell, right?
A.
What we're doing here is we're gonna sort of go through a couple quick examples of the development of math skills in the human brain from preschool through like early kindergarten. And that's what these tasks are showing. So in preschool, children are starting to really get that internal sense of, oh, this quantity in this bucket is a lot bigger than this quantity in that bucket. But it's got to be a big difference in quantities at first when kids are really young. This is maybe even before preschool, you know, like a really young age. And then, you know, what about this quantity? What's greater, A or B? Right? We can still tell that A is greater, but they're a little closer. You know, as kids get older, they start to be able to quantify and get a sense of quantity for sets that look increasingly similar, but there still has to be, you know, a noticeable difference. Now, what about subitizing? All right, how many dots are going to flash on the screen here? Subitizing is our ability to, instead of counting, just be able to know how many things are there by looking at them. Whoops, that's not what I wanted. Okay, how many dots? 2, right? You were able to subitize that. How many dots there? 3. Okay. What's the quantity is greater here? Which quantity? Now it gets a little tougher. You almost even have to count, but you can kind of tell that it seems like A is a little bigger, right? So as we get into like preschool and kindergarten, we start to be able to say like how many of a thing. It goes, you know, from the pre-preschool years, like the birth to 3 years of sort of sensing that one quantity is greater than another, to getting where the quantities, where you can do that when the quantities are more similar to each other. And then it gets into, as you're in the school years, like preschool, kindergarten, where you can tell how many of something is there and name the number. You could tell when a set is even pretty similar to another set, that one has more than another. You start to refine that sense, right? And then as you get, of course, into like maybe preschool, maybe early kindergarten for some kids, you're starting to match the actual quantity, the actual exact quantity, with a written numeral that represents that quantity, right? So that's sort of a quick trip along the path of a type of math development in the human brain, sort of that development of a number sense. Okay, and it all starts, our sense of our ability in math really all starts with developing a number sense. Dehaene says that number sense is now considered one of the major domains of human competence. Number sense is something we develop mostly through incidental observation of the world and the events around us. In sighted individuals, development of number sense relies heavily on our visual system. I'm going to show more specifically into what specifically that means. So for some people with CVI, such as children who have CVI, number sense may not come as naturally and incidentally. Many of my students, for example, require thoughtful and intentional scaffolding to develop the number sense. But why is that? So let's start with a quick review of that visual brain again, that ventral and dorsal stream, but specifically how it relates to number sense, right? So what Dehane and his colleagues and a lot of other neuroscientists have found and corroborated is that really our sense of quantity starts to develop in our parietal lobe, our parietal cortex, which is part of the visual dorsal stream, right? And we also, well, I'll get to that in a sec. So that's where we start to develop our sense of quantity, of how much is there a lot or a little, right? And eventually, from that, we start to develop a sense of written numbers. When it comes time to recognize the printed number, that's more of that visual recognition that happens in our ventral stream. And the two streams have to talk to each other in order to match up that quantity with the written numeral. And the interesting thing I found from Dehane's work is that our frontal cortex, which is involved in both dorsal and ventral stream, has connections to both of those streams, is thought to be responsible for combining the two, right? Even though there's crosstalk between dorsal and ventral stream, Dehane and his colleagues are finding that the quantity and numerals seem to be combined in our frontal cortex. One fascinating thing that I learned from his work too is that, you know how usually we think of recognition of single numbers and letters and faces and objects and words and all those things to be kind of a ventral stream temporal lobe task. He was saying that our sense of quantity in the dorsal stream is so strong, and that area is so related with mathematics in that parietal lobe, that in addition to developing the ability to recognize numbers in our temporal lobe, we're also using our dorsal stream. When we look at the number 2, our dorsal stream is actually activated as well in a numerical way. So I just thought that was really interesting how powerfully that area seems to be connected with mathematics and quantity. So again, just to show these just to remind us of these that we looked at yesterday, this CVI control, if we look at the occipital lobe right here where my arrow is, this is a really underconnected dorsal stream right here. This is the parietal area right here, that lack of connections right there and connections between the occipital, parietal, and frontal lobes. If that's the area of the brain where most sighted individuals are developing number sense, then it was less surprising to me that many of my students were having difficulty with some of these basic math skills. From Dutton's work, we know that the most common pattern of visual stream impairment in kids with CVI seems to be to have both dorsal and ventral stream at once being impaired. The second most common seems to be just dorsal stream impairment, and according to Dutton, the most uncommon is to just have isolated ventral stream impairment. So in other words, just difficulty like recognizing faces, or just difficulty recognizing objects or letters, but no difficulty with any other types of visual skills. So anyway, just thinking if the development of number sense in mathematics is primarily happening in our dorsal stream, and that's the area that's most often impaired in kids with CVI, those higher level dorsal stream tasks, that visual spatial stuff, then no wonder maybe that math can be difficult for some kids with CVI. All right, so he says that the parietal cortex, or the dorsal stream, part of the dorsal stream, is the place where quantities and symbols meet. Parietal cortex is the foundation of mathematical learning. Okay, so this was some really interesting research from Dehane. When most of us look to the left side of visual space, we know this, right? As vision educators or parents, that when we look to the left side of space, it's our right occipital lobe or our right parietal lobe that is being activated, right? Our occipital lobe for visual fields, our right parietal lobe to have a conscious sort of spatial awareness of that left side. And when we look to the right side, when we're thinking about the area on our right side, it's our left occipital lobe for fields, and it's our left parietal lobe primarily for processing that, or for being aware of that right side of visual space, for having that awareness. And what they found, which was really interesting, is that when people subtract numbers, this is people without visual impairments, when they subtract numbers, their right parietal lobe is active, as if their mind is looking to the left as the quantity decreases as they subtract. When we add numbers, our left parietal cortex is active, as if our mind is looking spatially to the right, visually, as we're adding and increasing the quantities. So we're doing our visual system is very active in most of us when we're doing even the most basic math. We have an internal sense of number line in our parietal cortex. When we do math, we visualize this number line as occupying the left to right side of space as the quantities increase. And I just found that fascinating. And he says that for some people, the number line is more of a vague, kind of dim sort of visual phenomenon that they might not even be conscious of, but in a functional MRI, it's showing that that area of the brain is active when they're doing number line tasks or when they're imagining addition and subtraction. But then for some people who report being really good at math, they report sometimes really vivid imagery of number lines in their mind. They can almost see them. So what are the possible implications for some kids with CVI? Well, here were some patterns I was seeing among my students that made me want to do all this research. So many of my students were having difficulty counting. Like if you asked them to count an array or a line of items, they would often skip some of them, they would double count other ones, and usually not come up with the correct answer. Difficulty recognizing numbers, right? That ventral stream ability to recognize numbers versus letters or words. Difficulty with word problems, right? And I was wondering, could this be partly related to difficulty visualizing word problems? And we'll get to that tomorrow. I was also noticing that many of my students had difficulties with judging quantities, like telling if one pile was greater or less than the other, or if one number was greater or less than the other. And then finally, difficulty recognizing shapes, which I've seen in a lot of my students, I think, often attributing it to that possible difficulty in ventral stream recognition, like complexity of object. So when I first started off, I was like, I got to consult the research on children with CVI and math skills. And so here's what I found. Nothing, right? Nothing. I mean, like when I would go and Google specifically, like on a university research database, mathematics and cortical visual impairment, mathematics, cerebral visual impairment, nothing would come up. So I thought, okay, if there's not specific research on children right now with CVI in math, there's got to be something out there for people, for teenagers, adults, like all these people that sort of report different types of neurological visual impairment, brain-based visual impairment, all that type of things. There's got to be something, people with traumatic brain injury, like there's got to be something that will at least have shown a body of research that is somehow tangentially related, where it's like people with dorsal stream dysfunction, even if they're adults, even if it was acquired, how do they now experience math? And do I see any of those same patterns in some of my younger students? So I came across this book, which has been phenomenal. It's called The Number Sense: How the Mind Creates Mathematics by Stanislaw Dehaene. And this is really where this sort of like launched me on this whole journey of just trying to find out more about how the brain processes vision, what happens in adults when those areas of the brain are impacted through visual impairment, and then how that might relate to some of our students, our younger children with CVI. So what about looking at difficulty with simultaneous visual information or difficulty with complexity of array? Okay, so we know that that kids with CVI often have difficulty with complexity of array, right? In the literature on cerebral visual impairment or in the neurology literature, it's often, I think, talked about under the umbrella term of simultanagnosia, or difficulty seeing multiple pieces of visual information. All right. And so let's take a task that for someone without a visual impairment or without CVI might come really easily, right? Which has more, A or B? Well, let's imagine if we have simultanagnosia or if we have difficulty with complexity of array and we can only see one group, right? Maybe we can't see both groups and we're looking at B and thinking, what do you mean which group has more? I only see one group here. Or what if we can see one or two dots in each group, but we can't really compare them because we're not seeing all the dots at once in the same group, or any other iteration or variation of that. So I think, simultanagnosia or difficulty with array can really, I think, impact this type of development of incidental learning in developing sort of an internal sense of quantity and comparing numbers, right? Because if you can only, now what about subitizing, right? Telling if there's two things or three things or four things or one thing. Well, you can only subitize if you can see more than one thing at a time, right? If the quantity that you're trying to subitize is more than one, you have to be able to see more than one thing at a time. If you can only see two things at a time, then it would be really impossible to subitize 3 or 4, right? So I think it's also important here and there when I present on math, I like to sort of try to demystify this a little bit and say that we all have our thresholds for how much we can subitize, right? So if I were to do this, how many are, I'm about to flash a group of dots on the screen. See if you could tell me how many are there. Okay, how many dots were there? You probably couldn't subitize that in the same way that you could if there were only 3, right? We all have our limits for how many we can subitize, and once it increases that threshold, we have to count, right? Well, for students with CVI, I just think that sometimes those thresholds for subitizing might be a lot lower for some kids, just because of that difficulty seeing more than 1 or 2 things at a time. I have other kids with CVI who subitize really well, but it's just something to think about. What Dehane and his colleagues were finding is that people with simultanagnosia tend to have significant difficulty with counting. And basically, what him and his colleagues say is that when these individuals were asked to count, they would often miscount. They would usually skip some of the items that they were counting, and then they would double or triple count other items because they weren't sure which ones they had already counted and which ones they still hadn't counted. And one of the patients said, and one of the subjects in the study said, I know there are many, but I only see one. So it's like he had this vague visual sense that he was looking at like some sort of a group of things, but he was only really aware of the position of one of those things at a time. And it's hard from that to even imagine, I think, for me, what that would look like. But I think that explanation just gives us a sense of how deep that is. He also said that these same individuals had difficulty looking at complex visual scene pictures, and that they tended to only notice 1 or 2 details and have trouble seeing the gestalt or the whole picture, which is, again, what many of my students tend to do. So I was seeing a lot of parallels with my students and how these adults were performing on some of these tasks. Dehane says that the reason for the counting difficulties for these patients was a direct result of their occipital parietal lesions, their simultanagnosia. Due to simultanagnosia, they had difficulty applying spatial tags to the items they had already counted. As a result, they were unable to label each item as counted already or not counted already. This is why they skipped some and counted others multiple times. To me, this sort of like confirmed a hunch that I had about why my students were doing this. I figured it was a visual spatial thing in difficulty keeping track of what I've counted, what I haven't, but wasn't able to go as far as like that it was directly related to possibly that simultanagnosia, and that this whole idea of spatial tagging was new to me. And I was thrilled to learn it because it gave language and words to something that I was noticing and trying to figure out for my students. So for Aiden, who we've talked about in the 2D image section, you know, just to give an example of this sort of difficulty counting, I'm going to show you with my pointer. You know, around the time of kindergarten or first grade, if his paraprofessional gave him an array of manipulative dinosaurs like this and said, okay, count these, he would do something like this. 1, 2, 3, 4, 5. You know, so he would, like, just like Dehane was saying, he would skip some and he would double count others, and his sort of pattern of counting them didn't really have any sort of logical left to right or up or down. It was sort of haphazard seeming. So what his paraprofessional did, and this was way before I read anything by Dehane, his paraprofessional figured out, I'll show it in a second, actually. First, I was going to show actually a couple of difficulties kids had, and then I'm going to show you how we used color to help it work better. This was another student, Kara. She was a student who, she had, I think, what we would probably describe as more of like the cerebral visual impairment, where, you know, there wasn't really that presence of the 10 characteristics from an early age. She wasn't diagnosed till she was in late elementary school because her team noticed like some kind of strange visual things or visual behaviors. And she didn't seem to have, she didn't seem to have all the characteristics, maybe a few. But one of them was simultanagnosia, difficulty, seeing a lot of things at once. And so I would go observe her in class, and her teacher, when I went to observe her, she didn't have any TVI services yet. It was like a one-time consult at first. And what I was seeing is she'd be sitting at her desk with, a tens frame like this that she had to count the dots on it. And she would be miscounting and skip counting. And her teacher would be saying things like, Kara, come on, pay attention. You're too distracted. Pay attention. You can do this. You're not paying attention. You're not trying. And the girl was getting more and more stressed out. She was getting upset. She was having behaviors. And, it seemed pretty evident to me that this was a visual thing that had to do with simultanagnosia or complexity of array difficulties. A different student, I'll call her Maya, had a very similar situation happening where she was just been diagnosed with CVI. Her team didn't really understand it yet, and they were giving her things like these Unifix cubes and asking her to count and make tens, like a tens unit out of them. But the problem was she couldn't really keep track of her count, how many were there. And she was doing this similar pattern of like skipping some and double counting others. All right, and then here was an example of a student who I'll call James, who this was a page from a district-wide math competency assessment, and he got it wrong. He was supposed to look at this sequence of patterns of dots, and he was supposed to circle the pattern that would come first. The problem was I knew his vision quite well from years of functional vision assessment, and I knew just by looking at the problem why he got it wrong, or I could figure I was pretty certain why he got it wrong. Was that he has difficulty seeing more than like maybe 5 or 6 dots at once. So all of these have at least 6 dots in them, the 2, 3, and 4 items, parts of the pattern. And I was pretty sure he wasn't really seeing what the quantities were in each of these. And so how could he possibly tell what the first part of that pattern was? Okay. So what Stanislaus Dehaene also has noticed is that participants did better when they had more time. So thinking of that latency or time of visual processing characteristic, when they had more time, they made far fewer errors. They also made fewer errors when items were arranged linearly or canonically, meaning like, how like on the 6 side of a dice, that they're arranged in that certain pattern. On the side of the dice where there's 4, they're always arranged in that certain pattern. When it was familiar patterns like that they could look at all at once, they were able to memorize, oh, this is 6, that's 4, this is 3, because it was in a certain pattern. And then participants, I think this is the most critical when it came to some of my students, was that participants performed better when each dot to count was a different color. So here we have adults with CVI, not even talking about, adults with brain-based visual impairment. The authors aren't even talking about CVI in children, but they're already talking about complexity, and they're talking about using color to help overcome complexity. And Dehaene says, the core deficit of simultanagnosia is a failure in using spatial tags to refer to individual objects. And I should specify visual spatial tags, because when some people were asked to do it tactily, they were able to apply tactile visual tags, but the visual was the hard part. Because all of the rectangles in our quantification task were physically identical and were distinguished only by their spatial location, it is perhaps not surprising that simultanagnosic patients had difficulties knowing which of them remained to be counted. However, this also suggests that counting performance should improve considerably if we were to differentiate the counted items using features other than spatial location. So if all of the items to count are the same color and same shape, then the person has to rely just on visual spatial tagging in order to figure out which ones they haven't counted yet. But if we use shape and color differences to help them tag which ones they've counted or not counted yet, if we could give them other ways to tag what they've counted, then that takes that visual spatial difficulty somewhat out of the equation. So here's what Aiden's brilliant paraprofessional did without any input from me. She knew that color was helpful to Aiden, but she came up with this all by herself. I wasn't even there. And she said, well, okay, what if we arrange it linearly? And what if we use a A-B color scheme? Maybe that'll help him keep track of what he counted and keep his place. And it worked amazingly. And this is actually what got me started. Her idea is what got me started on this whole, you know, path of like figuring out how alternating colors can help kids keep their place when reading, different math activities and things like that. It was all started with a paraprofessional who was like 19 at the time. Okay. So what did we do to help Kara? So for Kara, what we figured, we tried a bunch of different things, but what ended up helping her was to differentiate the beginning point, the top left, with a certain color. We used green, like go. You know, start at the green, start at go. And then we alternated the colors, you know, again, taking this from the paraprofessional's idea from years ago. We alternated the color of dots to help her better tag spatially which ones she's counted. And then we would put a red marker at the end to kind of give her that path of where she was going. And once we started instituting this, we also made it bigger so we could put more space between the dots too, to kind of decrease complexity. And that worked for her. So this is what worked for her. Okay. We used alternating Unifix cubes for Maya, and it worked. She was able to count and tell if there was 10 or 9 or 8. And it was just, again, it was that ability to use color as a tag so that she didn't have to rely completely on visual spatial tags. I don't show many tactile examples in this presentation, but I should also mention that a lot of what Dehane found in his work is that the part in our visual system, that parietal cortex, that is responsible for a lot of this math development is actually multimodal. So he said that if people are trained to do some of these tasks auditorily or just tactily, that a lot of the same areas of the visual cortex become activated as if they were doing it visually. So this whole internal representation of math, according to Dehane, can be built using visual, using tactile, using auditory, or any combination thereof. So very, very interesting. So what
Matt?
yeah.
Your bar is back.
Oh man, the bar is back. Increasing the visual complexity. All right, thank you. What we found for James is that if we gave him a lot of things to count and it was too much for him to use his visual spatial tagging, we just give him dot paint marker and he would just dot each thing he counted, and then he could tell how many things were there and he would count accurately. The Counting Bear app helped one of my students. Excuse me. I think it was actually Kara, who I tried it with first. And what the Counting Bear app does, it's pretty visually simple. You know, I mean, it's got, unfortunately, the bear at the bottom and then, you know, a little bit of complexity, but not much. It's mostly just the items that you have to count. But the nice thing is that as you count each item, it dims the item and it also puts a colored number above that item. So it tags for you which item you've already counted. And the interesting thing about seeing Kara do this is that she was still doing work. Like when she was counting 4 or 5 or 6, she was still having to use that visual search of that dorsal stream to find like where things were in space and then like use Visually Guided Reach and tap them. But it was supporting her enough where it became much more comfortable for her and not visually impossible, not visually overwhelming. And you can set the ceiling on how high you want it to go too. Okay, so here's some tagging strategies that have helped me replace the visual spatial tagging when it comes to some of my students. So some of them I've already talked about, right? Using that a different color for each item, using an alternating AB color pattern, using any sort of visual marking or checking or dot paint or magnets or stickers or stamps, any kind of visual system that the student likes that they could use to mark which ones they've already counted. Teaching tactile counting methods that don't rely on visual spatial skills, and sorting, like sorting counted items into a counted bin, reaching into the not yet counted bin for the items that haven't been counted yet, moving them to the counted bin. You know, all these other strategies too that take the visual spatial element out of it a little bit and support it either visually or tactily, or both. And then finally, having, like Dehane suggests, having the student count a set of different things rather than having all the things be the same, right? Instead of count like the 8 pencils, why not count how many things are on your desk and each one is a different thing, you know, to help them with that spatial tagging a little bit. Okay, who can tell me how many boxes are on this rectangle here? Give it a shot for a second and just try, even if you want to use your finger, try counting them and see how far you can get. I'm just going to take like maybe 60 seconds for this.
We have some guesses.
Really? I'm guessing these are estimates. What's a guess?
We have 400, 200, 350.
Okay, so these are guesses. Okay.
Yeah.
But can you actually, like, so the idea here is that if any of us tried to, even using our fingers, tried to point to each one as we count, we still have to use that dorsal stream to apply a visual spatial tag to each one that we've touched and each one that we haven't touched and put them into two separate categories. We don't have enough file folders in our dorsal stream to do that for this amount of dots, right? So all of us have a threshold for how many things we can count using just that visual spatial tagging strategy, right? So any of us, I think, would, if we really had to count and figure out how many dots would here, would probably use some kind of system of marking each one with color as we count, right? Something like that. So our students have that same kind of issue a lot of times, just at a much lower threshold. All right. And another analogy I like to use is think about when we're at the supermarket, right? You ever have, whether it's on paper or whether it's on your iPhone or smartphone, you ever have a list to count and you forget a pen, or you're just being, sometimes in my case, being lazy, and I'm not deleting each one from my notes app as I go along. And you got this list of 30 things, and oh my God, you can't keep track of like which ones you've already found, which ones you still have left to find. It's like overwhelming to look at it. It's visually tiring and fatiguing. If this guy forgot his pen and he's got 30 items on his list, it's going to be quite a visual chore to try to keep track of what he's already got on the list and what he doesn't. But you have that pen, you cross each thing off, and that's just a natural way that we all compensate for our difficulty with trying to solve these types of things using only visual spatial tagging. We want to use pen tagging in this case to actually write down check off what we've already been to, what we haven't gotten to yet. So again, our students might need that same type of thing with lots of things in life, not just math, but at a much lower threshold. Okay. This is almost the end of the math section. So, research has shown that a multisensory approach, this is from Dehane again, a multisensory approach helps people with simultanagnosia perform math tasks successfully. Working with manipulatives was really helpful to people with simultanagnosia versus just visual. And also I mentioned just that whole seat of number sense in our parietal lobe uses information from all the senses. So whether we're using vision as the student's primary approach to math, whether we're using tactile or auditory, or often probably some combination of all three, it's going to be reinforcing the same area of what we think of as our visual brain, according to Dehane's work. Then finally, individuals with ocular impairments who have no functional vision can learn math very well just through tactile and auditory means. And it's often represented in the same areas of the visual cortex when a person's doing it through manipulatives. Okay. All right, and this is the last, this will be, I'm going to post this PowerPoint someone just needs to mute, sorry. Yeah, there's somebody talking in the background that's not muted. There we go. I think that's better. All right, so this is the end of it, and this PowerPoint is going to be posted along with the other ones in the handouts for day 2. I'll do that like right after we end today. And so I just put together this little chart of the 2 CVI range characteristics, difficulty with complexity of array and difficulty with complexity of object or target, and then sort of like a description of what those mean, potential math areas impacted, potential supports, and then overall support categories that I've kind of used with my students. I think what this is light on, because I've taken in my whole career really much with kids with CVI, a much more visual approach to a lot of the strategies, using tactile approaches as well, but usually only in conjunction with vision. And so I think there's probably some of you out there who have much better examples of the tactile and multisensory examples you could bring into this. But I sort of go heavy on the visual here only because I feel like that's the area where I've done the most research and can add the most to what you might already know. So anyway, so it's heavy on vision, but that doesn't mean that tactile and auditory strategies won't work well too. It's just that I'm sort of coming from my experience here in this chart. And the last slide in this section is what I call the CVI iceberg, right? An iceberg is kind of like almost a cliche in how often it's used, but I think it really applies to CVI. And it's the mental image that I form in my mind when teachers ask me things like, all right, Matt, so let's just talk candidly here. How much of this student's difficulty with reading is visual and how much is cognitive? they can see it okay, right? Or when they say that about math, how much of the student's difficulty with the coordinate plane is visual and how much of it is really just their cognition, right? I hear that all the time. And I like to say, and whenever I hear that question, this iceberg pops into my head, and I start explaining that there's sort of a surface level impact of CVI that we can maybe see and address in the moment when it comes to accommodations, but that's the tip of the iceberg. That underneath, behind the scenes, we have to consider CVI's thorough impact on a person's concept development and a person's access to incidental learning throughout their entire life so far up until this point, and what impact that might have on their seeming ability to understand certain concepts. So just giving the example for math, with math, if a teacher comes up to me with a math test and says, well, how do we make this test accessible to the students so their vision, so they can get it, right? So on the surface level, there's that, okay, is the spacing good enough? Is there only, for this student, maybe we can only have 2 problems per page and no more. For this student, we might need color coding to highlight the difference between the operation signs. All that stuff I see as sort of the tip of the iceberg, surface kind of in the moment, has the accommodation been made so they can see it? Okay. But then I would say, but what about how these concepts have been taught to this student? What about, if they're having trouble with number sense and quantity, regardless of how accessible we've made it on the test, if they've had trouble grasping this concept, we can't even begin to draw a line where CVI's role begins and ends with that, right? Because of all these things that, we know happens in the parietal lobe when it comes to basic math skills and stuff. So I think it's like, I always try to stress to teams, we've got to think about how to make something accessible in the moment, but also how to design our teaching strategies and approaches so that they're accounting for how CVI could be impacting the student, and how we can maybe come up with ways for the student to learn this task with that in consideration. So, all right, and I would just say that for much more on this topic, my CVI and the MathMind presentation is all about 2.5 hours long on Perkins CVI Now, and also on YouTube. And it's really like everything that I've learned about math and CVI up to this point. And then I realized, though, when I was doing this studying of math and CVI, that the topic, because I was really excited to come up with a presentation like that and present it to people, and hopefully it would help them with their students like it helped me with mine. But I was also very aware that this isn't some area of CVI that I can just sort of grab a hold of and become some kind of expert in or something like that. It's way too vast for me. It's way too deep. I feel like I can only scratch the surface right now. I'm not a math teacher. I'm not even necessarily that experienced in teaching more advanced math to kids who are ocularly blind. And I think some of those tactile strategies combined with the visual could be really helpful in helping build that number sense for kids with CVI. So I felt excited to be learning all this and had a certain amount of it that I could share, but then I also felt way out of my depth. So I thought, I think the only solution here would to be try to bring a community together and create a study group, a community where we could just meet informally and just share ideas and strategies. My vision for this is that math teachers would be involved, TVIs, parents, individuals with CVI, and more different types of teachers, special education teachers, anybody, neurologists, And so far we've had, so we started the CVI and math study group through Perkins, and so far we had 3 meetings last year, and we had a lot of participants internationally for each meeting, up to 80 participants in one of the meetings from a whole bunch of different countries. There were parents, there were individuals with CVI on every one of the meetings. There were math teachers on a couple. There were lots of TVIs. There were some special ed teachers, and some of the things that especially the parents and individuals with CVI shared, were just so eye-opening for me, and already have given me things to do to help my students. So anyway, this is something that we're going to be continuing into this fall, and we're going to have at least another 3 meetings this year where we just meet informally on Zoom and just share ideas. So if you have strategies that you've used with students that you want to bring to it, if you have questions that you want to bring to it, just show up. If you know people that might be interested, just show up, and it's a big kind of share type of deal. And my hope is that relationships between different professionals will grow naturally out of this, and that will sort of accelerate and speed up the type of collaboration across disciplines that it's going to take to really get somewhere with understanding math and CVI. So thank you very much. It's 4:47. I guess I can sort of like just jump into a little bit of coloring complexity. But before I do that, we can also just spend the rest of the time talking about this and seeing if people have any questions.
There is a comment in the chat box, Matt.
Okay.
So Mara wanted to thank you for the last comment and image. There's so much to talk about accessibility, but that is not enough to address the loss of incidental learning and concept development that comes from the failure to address the CVI early on. Our kids need the specially designed instruction also that takes into account the unique educational needs attributed to their CVI also. Also, your caution not to simply write it off as cognitive issue. If alleged access alone was the only factor looked at, it was very appreciative.
Oh, thank you. Yeah, you're welcome. I mean, that's, I think that's a message I hear not only my students, but also just I hear from so many other people at conferences and at our different communities online. That's so so common, just that people with CVI are often misunderstood and written off as, well, they just don't get this, so we're gonna make it cognitively more simple. And for some kids, that might be what needs to happen. But I think for a lot of kids, it's not appreciated how their CVI in different way of processing the world can impact them. I mean, you figure if a child is ocularly blind from an early age, then everybody knows you can't just show them a math worksheet and expect them to learn math visually, right? Everybody knows that because their visual impairment is more obvious and visible. And so they teach them tactile ways. And I've had students with, I've had students who are ocularly blind, who are Braille readers, who are better at math in 10th grade than I am now, and who just blew me away. Like I'd be like struggling through their Nemeth code, trying to like figure out why they got an answer wrong, and they're explaining it to me. I mean, just incredible, right? But I think the problem for a lot of kids with CVI is that they're not taught like a child with ocular blindness because they're not ocularly blind, but then they're also not given they're not giving an appropriate visual way to learn, because sometimes people assume that they can see it, so it must be fine. Their eyes can see it, so it must be fine. So it's almost like they're in this weird limbo where they have trouble accessing it visually the way it is without modifications because nobody's realizing what's going on, but yet they're not blind enough where professionals have realized, oh, we got to give them some other way to do this. So I think a lot of times for me, that other way has been, let's adapt it visually and use sort of manipulatives in a secondary way as a way for them to understand this. And let's adapt it visually so they can process it. But my thought is that there's probably other kids out there that would benefit even from more creative tactile methods from what I've learned, from what I've tried too. And so I think with this math and CVI study group, if you're somebody who has done a lot of work with CVI and you're excited to share what you have, or you have a lot of questions, please come. But if you're a TVI who's worked mostly with kids with ocular blindness, who has a lot of experience with creative tactile or auditory methods, please come as well, because I think we need to integrate the two for a lot of kids with CVI. And some of my favorite interventions have been one that use manipulatives and tactile strategies that are also visually color coded. So the students like getting both. And for a couple of my students, those have worked really, really well. But thank you. Okay, well, maybe let's see in the 9 minutes. I'm so bad with time and going over time that I think I will, in an effort to get a head start on coloring, on this whole idea of color as a support, I'll just spend 8 or 9 minutes on this, and then we'll end for the day. This is to me another fascinating topic that I love presenting on. I don't do this one that often though, and I've updated it a lot since I last did it. So I'm hoping there'll be a lot of just interesting information to think about here. Okay, so I'm gonna, oh, for goodness sakes, let's see, let's gotta get that. For some reason, every now and then the auditory will take over. It's like, whoops, in that bar. Okay, let me just get rid of that. Okay, I'm gonna go to transitions. I'm gonna go to, it's like so jarring. Okay, transitions, whoosh, we gotta get rid of the whoosh. I'm going to get rid of the whoosh, no sound, apply to all. All right, so hopefully that'll work. One time it didn't, but we'll see. Okay, from beginning, and get rid of this thing. Okay, so coloring complexity. Color as an enduring visual support for children with CVI. And I want to just give the caveat again that like sometimes I worry that I, without intending to, might overgeneralize some of this. Like color, I think, is a support powerfully for most of my students with CVI to different degrees. If you have a student with CVI who's ocularly colorblind, or even, you know, rarely, but it happens, who is ocularly blind, who is colorblind because of their CVI, I've encountered that once. It's not going to work in the same way for them, maybe, right? But for the, and I had another student whose certain colors are really hard for him to look at, and color increases the complexity, and he's told me that, and so we don't really use color coding in the same way that I would use it for some of my other students. But in general, I found that when I'm using visual strategies with my kids with CVI, color is probably my number one go-to, one of my number one go-to multifaceted strategies. And I'm going to go, hopefully, really deeply into this in a way that even if you've been using color for kids with CVI for years, I'm hoping that that the variety in this presentation will give you something new to think about it, or a different way to think about it, or new things to add. Okay, so just to start, color is a powerful visual support for many children with CVI. It tends to be a visual anchor, right? Christine Roman Lancy was like, kind of like laid the foundations for me for that. And one of the things I learned at the CVI Phase 3 boot camp in Maryland, that was sort of that one of the most important things I think I took away from that was how it goes way beyond just that initial preferred color that kids may have earlier on in the CVI range, and it extends well into Phase 3 and never really resolves for a lot of different reasons. It just looks differently as kids' visual skills change. Every single one of my students with CVI in all phases benefits from color as a visual support. That would be every kid that I've done the CVI range for. For a few of my kids, like I mentioned, that sort of are a little bit of outliers when it comes to color, not so much. But I'd say like, you know, 95% of my kids with CVI have benefited from some use of color as a support. And I feel like this goes way beyond just a preference for a particular color. All right, so what I learned from that CVI Phase 3 boot camp was that the extent to which a child with CVI needs, basically, what's the heart of the color characteristic? What is it all about at its core? And it's really about this, the extent to which a child with CVI needs color as a support more than her typically cited same age peers. That's from Christine Roman. Color as an anchor never really fades, just manifests differently throughout the phases. Okay. So in this presentation, we're going to take a look first at, this is one of my favorite parts, looking at how color helps all of us deal with our own natural thresholds for visual complexity in ways that many of us probably don't even think about consciously on a day-to-day basis. I know I don't. I just kind of think about it when it comes time to do a presentation or work with a student, and I kind of make these analogies to my own life. But I usually go through my day kind of blissfully not noticing all the ways that color strategies have been employed to make things easier for me to see. We're also then going to look at how children with CVI need color often even more than people without CVI. I'm going to talk about why the color characteristic rarely resolves and why we can use color as a support in all three phases. Okay, so color helps us all. It goes back to like these two images, I think, right? When our brains are faced with that monumental computing task of turning all of this jumbled raw data, this isolated raw data, into a meaningful, understandable gestalt, our brain's got to use a lot of different strategies to help this happen. This is a very, very complex process and task. So how does our brain do it? Well, I think that there's a lot of different ways to answer this, but I think Gestalt psychology has some very useful answers when it comes to thinking about CVI and about how our own vision works. And I'll finish after this slide. This will be the last slide for today. Psychologists in the early 20th century, the Gestalt psychologists, were very interested in discovering what rules or what principles our visual brain uses to decode all that data from the retina and turn it into a coherent visual scene made up of distinct related objects. How does it do that? Okay, they wanted to answer that question. how do all those local features, all those individual dots combine into the larger perceptual units that we see and that result in object recognition? How do our brains decode all of that? Okay, so one of the things they found was that when we look at a visual scene and we're bombarded with all of that visual data, that the elements of that scene are organized into perceptual units based on factors such as similarity. So our brain looks immediately for, out of all these bits of visual information, which ones have some element of similarity to each other and therefore must belong together. And one of the principles of similarity that our brains use is color. Color is a powerful visual cue that helps us determine how those local, isolated visual elements of a scene combine together into units to form the objects that we act upon in the world. So it really comes down, color is a big one. And let's end there. I'm going to pick up here tomorrow. Thank you very much. There was a lot of lecturing today. There's going to be some tomorrow, but then at least half of the time tomorrow, it's going to be a lot of video case studies of a student named Paul. And then it's going to be also each of you doing hands-on completing some of the what's the complexity profile for one of your students. So I hope it wasn't too much chatting today. But thank you for all the questions, comments. I appreciate it.
It was really fascinating, Matt. I think our brains are still on the math. I think my brain is imploding, but very, very good, interesting, helpful, very good, knowledgeable information. Really awesome.
Thank you very much.
So if anybody has any last minute questions, we literally have 2 minutes left and then we're going to end the call. A lot of great feedback in the chat also about that.
Thank you guys.
The presentation today was pretty incredible. So we agree.
Oh, thank you very much. Oh, closing code.
ACVRP, sorry guys. So the opening code was ocean and the closing code is breeze. So I will type breeze in the chat box. Thank you for the reminder.
No sign out needed. You guys are good. Tomorrow there will be an evaluation to do.
So we may have to prompt Mr. Matt to end like 10 minutes early tomorrow.
What? Okay.
We'll see. We'll negotiate. We'll negotiate. All right. So everybody have a wonderful evening and we'll see you tomorrow at 2 o'clock.
Thank you, everybody. See you tomorrow.
All right. Thanks, Matt. Take care.
Yeah, you too.